1 2 A 1 A. One A test. One one 1 2 1 2 8 8 1 2 1 8 8 8 1 8. Let's test a big sentence just for the sake of having both at the same time. Try and keep talking so it's all right. We are good. Another test. 1 2 A 1 A 1 2. Just keep talking. So we have two lines for the subtitles. Uh, we need to keep talking. Just it seems to be alright. If I do this, it will cut, and this will cut. Okay. We are good. I'm gonna.
Okay, ladies and gentlemen, we're about to begin, so please, everybody take a seat, relax. We're about to start, so please, everybody, if you can, take a seat. And a few quick rules, okay? Today, please, turn your phones off, or at least put them on silent. We really don't want any interruptions. And once we begin the summit, please remain seated, okay? No walking around. If you need anything, if you need any help, find our staff, okay? So you can see I'm wearing this badge here. Anybody wearing a badge is a staff member, so anything you need, don't hesitate to ask. And please be aware that we are live streaming this event. All right, we're about to begin, so photographer, I believe we're gonna get a photo, very cool photo from the stage, capturing all of your beautiful faces. You ready?可以摆个姿势。3, 2, 1，茄子。Cool. Okay, good morning, ladies and gentlemen, and welcome to the 2023 China-UK Technology Summit. We're honored to have so many distinguished scholars, experts, and entrepreneurs here. I'm your host, Toto Guo, Guo Toto. It says here, the ambassador of Chinese culture. I'm not sure that's correct, maybe a bit strong, but I do love to share Chinese culture through my different performance work, and being here today is a real honor for me. Now, I grew up in London, so I've got so many friends who have come from China to study in the UK doing their post-grad. So to see so many people here today makes me feel really, really proud, and many of the people here today are my friends. The summit is being held by the China-UK Technology Summit Committee, collaborated on and supported by more than 200 institutions, the CSSA, Chinese Student and Scholars Association, venture capital organizations, incubators, media, and so on, from China, the UK, Canada, and European countries, and the USA, covering industry elites, experts and scholars, young leaders, entrepreneurs, startups, and eco-partners in various fields. Today is an annual feast combining the hottest tech achievements and emerging technologies, which will be presented to all of our guests. On behalf of the organizing committee of the 2023 China-UK Technology Summit, I'd like to express our most heartfelt thanks and warmest welcome to all of the guests and peers, friends from all over the world who are joining us today, whether it's you guys here at the venue or the people watching all over the globe online. The theme of this year's summit is reimagining the impossible, with common dreams and expectations. Today is a starting point for us to move forward together. So first up, we have some speeches from our amazing and very, very special VIP guests. Firstly, please welcome Mr. Ding Mingqin, Minister Counselor for Science and Technology Affairs of the Chinese Embassy in the UK. My friends, please give him a very, very warm welcome. Thank you.
Distinguished Professor Lindo, Professor Ochin, Professor Gu, distinguished guests, dear friends, good afternoon. It is a real delight to attend this summit and meet all the prominent scientists here. On behalf of Ambassador Zheng Zeguang, I would like to extend warm congratulations to the convening of this summit. Since the establishment of diplomatic relations between China and the UK, fruitful exchanges and cooperations in various fields have been carried out and brought tangible benefits to people of both countries. In the midst of profound and complex changes of the world, China and the UK have maintained dialogue and communication and expanded mutually beneficial cooperation, among them cooperation in science, technology, and innovation has played a key role. Over the past decade, China's science technology course has experienced major historic, holistic, and structural changes. China has become an important player in international cutting-edge innovation and a major contributor to solving global challenges. According to the Nature Index 2023, China's adjusted share of publications in the 82 selected major academic journals surpassed the US for the first time to take the top spot. China and the UK are complementary in science, technology, and innovation strengths. In the past decade, the number of co-authored papers by Chinese and British researchers showed exponential growth and rose to the second position globally. Data for 2022 suggests that China's contribution to UK's research output has risen to 11.4% of papers. Collaboration between China and the UK has enhanced the science and technology research capacities and productivities of both countries and provided new development opportunities for both sides. There are great potentials for China and UK cooperation in areas like green and low carbon technologies, advanced agriculture, antimicrobial resistance research, biodiversity entrepreneurs, and etc. Many significant and pragmatic China-UK joint initiatives in science, technology, and innovation were carried out in recent years. The two sides jointly launched the flagship challenge programs in agriculture, healthy aging, and One Health. Remarkable results have been achieved through these collaborations. We have confidence that China-UK cooperation in science, technology, and innovation will play an increasing importance in tackling global challenges such as climate change, public health, and food security, and so on. Today's summit will undoubtedly contribute to science, technology, and innovation exchanges and cooperation between the two countries. The Chinese embassy in the UK will as always, support to further exchanges and mutually beneficial cooperation in science, technology, and innovation between China and the UK, injecting more positive energy into the development of China-UK relations. I wish the summit a great success. Thank you all.
Thank you so much. Thank you so much, Minister Councillor Ding Mingqin. 我可以说点中文吗？非常感谢，非常感谢。And now, yeah, okay, 再来一次, huh? One more. And now it's my great honor to introduce Nobel Prize winner in chemistry and fellow of the Royal Society, Professor Thomas Lindell from the Francis Crick Institute to make a speech. Ladies and gentlemen, please, a big, big, big round of applause. Thank you.
Ladies and gentlemen, honored colleagues and guests. The topic of my short introductory talk will be some research recollections from my own work, and also towards the end some advice on your own research activities. A main interest of mine has been DNA instability, the cellular and organismal response to such potential deleterious DNA damage. Much of this work has been summarized in a recent review article for the Annual Review of Biochemistry 2023 that came out in the spring. So if you want references or more details of some of the new ideas, they should be available there. The title is DNA Fragility and Repair. The research problem here is that we investigated the stability of DNA chains and DNA bases under physiological conditions. It was anticipated that this DNA structure would be very stable because DNA is the carrier of our genetic information, and changes in the structure could easily result in mutations, including cancer-causing mutations. But by doing direct biochemical experiments, we found instead that the covalent primary structure of a DNA chain was unexpectedly labile. A DNA chain is less stable than a typical protein chain. I'd like to emphasize that this conclusion is not just a calculation, but it's based on direct biochemical experiments. Important double helical structure of DNA identified by Watson and Crick provides some protection of each DNA chain, but far from enough. The spontaneous loss of adenine and guanine from DNA at 37 degrees by hydrolysis is only 4 times slower in double-stranded DNA than in single-stranded DNA. It was already known that DNA chains are susceptible to radiation-induced mutagenic damage from UV light and ionizing radiation. But we could show that there is also a lot of potentially mutagenic DNA damage by reaction with water at 37 degrees Celsius, that is hydrolysis under in vivo conditions, and also damage caused by active oxygen. The most common change is due to loss of a purine base from DNA, that is, loss of an adenine or guanine residue. This does not lead to a break of the DNA deoxyribose phosphate backbone, but may result in loss of genetic information, that is, a potential mutation. Fortunately, cells have evolved DNA repair mechanisms, in particular the so-called base excision repair pathway, which is described in my review. But no repair turnover, no repair system is absolutely perfect and error-free. So there is a risk factor here with the ongoing repair. And the fact that DNA is not a totally stable molecule, it actually turns over, but at a slow rate. Another important factor is that there's nothing magic about body temperature of 37 degrees Celsius. There are many organisms that grow better or at higher or lower temperatures. In a person with high fever, the body temperature goes up towards 42 degrees Celsius rather than 37 degrees Celsius. And common bacterium, Bacillus subtilis, grows well at about 50 degrees Celsius. It has a close relative, the thermophilic bacterium Bacillus stereothermophilus, that grows well up to 65, 70 degrees Celsius, using the same type of DNA and DNA repair enzymes as other cells, although the rate of endogenous DNA damage at such a high temperature is 100 times higher than at 37 degrees Celsius. If you have such a bacterial culture growing in a flask in your laboratory, the flask is so hot that you cannot hold it in your hand. So DNA is, in conclusion, not completely stable, but turns over. And because of DNA repair, this is functional. We have characterized these repair mechanisms, and it's now possible, becoming possible, to switch off DNA repair temporarily. Well, why would you want to do that? If you want to damage a cell, like a cancer cell with radiation, you don't want it to be able to repair temporarily. So if you can switch off its repair functions, it becomes much more susceptible to killing by cytotoxic agents. And this is becoming a very promising method to deal with cancer cells and inactivate them. Final comment I will make is that a question I sometimes get from young scientists is, how do you approach finding an important discovery? A start here can be based on following up on unexpected results obtained in the laboratory. It's important to remember that if an experiment does not come out as expected, you have to be technically accomplished enough that the result obviously is not just due to technical incompetence. But unexpected results may not mean that you have done something wrong. Perhaps nature is trying to tell you something interesting that you and others had not considered before. In this situation, it is important that you have good relations with your boss so that you can take a little bit of time and use lab facilities to try to define your new research project. It is, of course, also in the interest of your laboratory if a new successful finding has been made there. So it's to everybody's advantage. I look forward to hearing about new research performed in China. And I'm very pleased and honored that a new laboratory in Shenzhen has been named after me. It is headed by Dr. Ningning Li, who unfortunately can't be here today. And we look forward to scientific questions studied in parallel here and in China. Events such as the China-UK Tech Summit are important steps towards increasing international collaborations, and we look forward to that. Thank you very much.
My friends, please join me in giving Nobel Prize winner in chemistry, Professor Thomas Lindell, one more round of applause. And now please welcome Professor Gu Sai, Deputy Pro-Vice-Chancellor at the University of Warwick and Fellow of the Royal Academy of Engineering, to make a speech. 朋友们，欢呼鼓掌 please. Let's welcome him on stage. Thank you.
So thank you, everybody. Particular thank you, Professor Linda's very insightful thought about research. So I'm really pleased to have this opportunity to come in here today. I think this is particularly important given for the last over 3 years, we don't have a chance to do the face-to-face meetings. And more importantly, I see today we have many academic colleagues coming here in their weekend. And so it does give us the confidence the science is able to fill the gap or the bridge differences and also many challenges we are facing with the Sino-UK relations. What I'm going to talk today, I'm struggling because I only have just a few minutes to prepare. I found it's very challenging to prepare something for such great event. So today I'm going to talk about challenges. So I'm from University of Warwick. I'm responsible for our partnership with China. So this is challenging at the moment. But I want to take inspiration from where Warwick started. When Warwick started in 1965, it's very challenging to create a new university, and also very challenging to build a new department. In the Department of Chemistry, they appointed one professor, Professor John Comfort. He's one of the brilliant scientists at that time. He was fantastic doing the experiment work, have exceptional experiment skills. While he was an undergraduate student, and one of the female students broken the Classen's flasks, and she was worried. And John came over, said, "Don't worry, I can help." So he used his exceptional and glass blowing skills to repair the flasks. And later, the girls became his wife. So you never know what sort of skill you require to find your love. But what most extraordinary is John was completely deaf, which will disqualify him as a lecturer. But he was appointed, and he became one of the most loved lecturers by the students. And then 10 years later, he won the Nobel Prize for chemistry. John has his disability, but he was lucky because his talent was recognized at very early in his research career. But there is another female researcher. When she did her postdoctoral research, she found a good position from Johns Hopkins University, but her supervisor didn't want her to leave and said, "I will have you deported and report you you are illegally staying in the United States. So she have to give up opportunity with Johns Hopkins. And more importantly, she couldn't find any jobs elsewhere for many years. As one day, she got a job at University of Pennsylvania on a tenure track, became full professors. She was very happy. She's doing some fantastic research in a particular area, but no one believed her this area is going to work. They regard it as research backwaters. So for many years, her application been rejected, and she was demoted by the University of Pennsylvania. Her salary be cut, but she insists, continue pursue her dreams. So when she couldn't find funding, she asked one of the colleagues, Professor John Weissman, to help her, to collaborate with her. She continues to pursuing her dreams, which is impossible, most people feel. Not for a few years, but for almost 3 decades. Her work laid the foundation for BioNTech and Moderna. And Professor Kathleen Caricos and Professor Joe Weissman won the Nobel Prize this month. So what it's telling us is there's many challenges in front of us when we started our career. Fortunately, I didn't need to overcome such challenges when I started my academic career. When I became a lecturer, I was very optimistic. I can do great things from what I learned from Cambridge. And I wrote lots of research proposals and hope I will get it. I can do a lot of fantastic research. But the reality is very different. All my proposals was rejected. So I reached a very low point. What am I supposed to do? Do I need to give up my research? So at that time, I thought I need to change my research directions. I cannot continue for what I learned for the last 3 or 5 years. So I need to learn from those who have been successful. So what I did, I looked at the university who is most successful in terms of establishing themselves, have biggest research fundings, and has well known in this area. So one is a chemical engineering professor, Tony Bridgewater. He was very, very well known in the bioenergy area. So immediately I made an appointment to see him. But when I see him, he said, "Why you came to see me? Do you know how busy I am? What you can do for me? Because we are from different departments. I was in mechanical engineering, he was in chemical engineering. He said, you need to talk to your head of department, not me." So he literally pushed me out from his office. So that is a setback for a young researchers starting to the academic career. But then I thought, I really need to think about what I can do for a big professor like that. So in a few months' time, I read most of his significant publications, and then I start to think what I can do to work with him. And then I write EPSR research proposals. I asked her secretary to make appointment again. When Tony showed me, he was very cross. He said, "Do you know how busy I am? I can't help even pull my head off." Of course, Tony doesn't have much hair left already. But I said, "Tony, I really appreciate your time. What I want to show you is a research proposal I wrote, and I want your advice." He was surprised. So Tony has the habit, because he was so busy, if he didn't do something immediately, he will either forget or have no time to look at it at all. So he sit with me in front of his computer to look at my proposals. So that half-an-hour appointment became over 2 hours. So we worked together to finish that proposal. That started our collaboration for 2 decades. And more importantly, take me into the wonderful world of bioenergy research. So I learned a lot from those academics who have been successful, but more importantly, I think we need to reimagine what is impossible. To conclude my talk today, so we come in here to discuss about the technologies. One of the most successful high-tech entrepreneurs today is Elon Musk. But when Elon Musk working on the Teslas, nobody believed he's going to work. And when he talked to the investors, most of the time he was very dubious about the possibility of success of Tesla. So in one of these meetings, the investors said, do you know how difficult to make a car? Do you know when was the last time America had a successful car company? And Elon answered, it's 1941, it's Jeeps. But what Elon said is, it's been 60 years since we have a successful car company. Now, this is probably time for another one. So Elon Musk is able to convince the people and investors, although he said Tesla and SpaceX only have less than 10% of chance of success, but they feel this is a journey worth taking. So what, for you brilliant students and researchers today, what I would encourage you is to chase your dream, ignore the expert advice like us, enjoy the challenges, and you will have a wonderful career ahead of you. Thank you.
Thank you very much. Thank you, Professor Gulsai. And now, please welcome Head of Department of Civil and Environmental Engineering at Imperial College London and Fellow of the Royal Academy of Engineering, Professor Washington Yoto Ochian, to make a speech. Please make him feel welcome. Thank you.
Thank you very much, distinguished guests, ladies and gentlemen. Mine is to extend a very, very warm welcome to you all in the hall here and also online on behalf of Imperial College London. So we were here, myself and my wife, we were here last year, and we loved it so much that we decided to come back because of the quality of the conference. Now, I'd like to throw a challenge to the conference in the sense that you will all have seen recently the challenges that the world is facing. I've tried to organize it in a pentagonal structure which has vectors, and I call them threat vectors. And these threat vectors could be natural, they could be biological, they could be cyber, they could be physical, and they could be social, including the human dimension. Now, threats emanating from those vectors individually we are used to, including the more recent biological COVID-19. But when they start to conspire in a simultaneous way, ending up with simultaneous multiple threats and beginning to actually manifest in reality, then the world is facing potentially existential circumstances. Now, I've been thinking about these threat vectors and how they conspire together in an increasing, devastating, and simultaneous way, and I've decided to call them societal security and resilience problem, in addition to the usual metrics of sustainability and so on. Now, if you're thinking about it in that way, you face what I refer to as a hyper-complex problem. And when you get to that hyper-complexity, which has those vectors in it, then you realize that we need a whole of society integrated approach. And that calls for everyone to work together, not knowing boundaries, because some of these threats do not know country boundaries and so on. So we must work together, we must collaborate, we must cooperate. Now, Imperial College London has 4 pillars, which are also interlinked, trying to address these particular threats, and we call them smart, sustainable, healthy, and secure societies. Now, the Department of Civil and Environmental Engineering, from which I come, and the Institute for Security Science and Technology are working together, and I'm delighted that 2 of my colleagues are here as panelists. And also, there are many, many PhD students and researchers from Imperial College London down the road who are participating and even organizing this particular conference. So the department, the institute, and even the space laboratory at Imperial working together to tackle these very, very serious challenges in collaboration. And by the way, Imperial College has probably got the strongest connection with Chinese research in the entire United Kingdom, for which we're very proud. So an initiative that the college has come up with recently is something called the Center of Excellence for Resilience and Security Research, trying to convene and conduct research that will, for the first time, address these simultaneous multiple occurrence of those particular threats. Now, that is a challenge enough, and I don't want to be alarmist about it, in the sense that you have seen recently temperatures going up to 50 degrees C, and then the following week we got flooding like we've never seen. So I don't think we can deny that the world is really facing potentially existential threats. So where do you come in, the youth? Now, those of my generation and the generation gone past have done or are doing their bit. Professor Rinthal was here, Nobel Prize winner, setting the foundation for you, the youth. So the idea here is that we've done a little bit, but if you look at where we are going, the challenge is to this conference and the youth in particular, to get together, to collaborate properly, to for the first time, and it will be for the first time, actually come up with solutions that preserve not only this planet, but also the universe as we know it. So I hope and wish you all the best in this technology summit, and hope that we can come up with tangible ways and meaningful ways of collaboration. So thank you very much indeed. Thank you.
Okay, everybody, please, one more round of applause for all of our speakers. Yeah, thank you all so much. Thank you. Okay, so now we're going to take a quick 5-minute break, and we'll see you all in about 5 minutes. Go grab a water, get a coffee. See you in 5, okay? Thank you.
Can you start the microphone? Hi,
Wait. Hello. Wait. Wait. Okay, ladies and gentlemen, we're about to start again, so please have a seat. I know everybody wants a photo with our celebrity, Professor Thomas Lindahl. You'll get a chance to take a photo later, okay? Everybody please take a seat, relax, we're about to begin. 朋友们，马上就开始啊，先坐。Thank you. Ladies and gentlemen, we're about to begin again, so please, you'll all have a chance to take a photo later.请坐。Everybody, please take your seats. We're about to begin again.
your mic is literally...
Yes, I'll be giving you your microphone. Yeah. I'll be giving you your microphone. Yeah, sure. All right, all of my friends, everybody, please take your seats. 请坐，马上就开始。
That didn't work, did it? It's getting there, isn't it?
Yeah.
You all got the microphone, I think it's all working. Perfect. Come on its own, I guess. I think so, or you say the magic word or something like that. I think that's something I do not understand from the control room.
Everybody, please.
偷偷说完了我们再看。是，我努力的把这个问题变得口语化了一点，努力的。喂。
Welcome back.
Okay.
Everybody, please have a seat, relax.
Just a quick word from the control room. Can you please not just not tap on the microphone? Do not tap. I think it just breaks the thing. Yeah, it's all here.
You don't have to do anything. They are live. Don't tap on it. Just speak into it. Close to your mouth. Thank you.
Please have a seat, relax. We're about to begin.
是吧？所有就是一些跟专业没有什么关系的事情，但是这个就是我们panel跟其他人不一样的，我们要让大家都听，因为其他人会想听这个，因为这个跟其他人有关系嘛，跟就是哪怕不学我们专业都有点关系。
好看的 summit 千篇一律，但是有趣的 China UK Technology Summit at Imperial College London 万里挑一。Yeah. Welcome back. Now, everybody, I was a little bit let down because I did hear the sound of some phones. So please, everybody, I know it's hard, but right now, put those things on silent, okay? Let's keep it silent, let's keep it chilled, and we want to hear the speakers really clearly. So now, it's time for our themed panel session. In recent years, our cities have become smarter, more resilient, and more intelligent. And this is thanks to advanced material infrastructure and traffic models, low carbon structure, and much more, turning what we thought was an impossible feat to reality. Today, let's delve deep into the realm of future city, discussing digital infrastructure, transport modeling, and sustainable structure and architecture. So moderating this session is my friend, Order Gomer Wilson Zhang, a student at Imperial College, and he's going to introduce all the amazing guests. Thank you.
Hello, thank you, and good afternoon all. My name's Wilson, and I'll be the moderator of this panel. And a bit of an introduction about myself, which you can see on the screen as well. So I'm a student studying at Imperial College London, doing civil and environmental engineering. And so our theme today is the future city. So as we all know, to engineer the future city is a very multidisciplinary discussion. And we need to work together to engineer this better future. And that's why we've got our 4 distinguished panelists to share their valuable insight and their expertise. And first of all, please allow me to introduce them. From my left to right, we've got the Director of Institute for Digital Innovation in the Built Environment at University College London, Fellow of Royal Academy of Engineering, Professor Tim Broyd. And Reader in Consumer Demand Modelling and Urban System at Imperial College London, Dr. Aruna Sivakumar. And the Professor of Structural Engineering at Imperial College London, Fellow of the Royal Academy of Engineering, Professor Lyric Gardner. And finally, Professor at Bartlett School of Sustainable Construction at University College London, Professor Meng Jing. And now, let's move on to our discussion. So my first question for you all is quite a general one. So as our summit is themed, Reimagining the Impossibles, the built environment has thoroughly transformed in the recent years. So what was an impossibility for you, and how was it broken nowadays?
You wish to start with me, sir. Look, this might seem very arrogant, and you hit me with that question about 10 minutes ago. So I don't think I've ever come across an impossible challenge. I mean, some things clearly have been impossible at a time, but technology catches up and other things catch up, right? So, for example, despite what it says I am up there, I'm a civil engineer by background. I was proud a few years ago to be the president of the Institution of Civil Engineers, and yet I find myself, I'm as surprised as anyone that I found myself in the Bartlett faculty of the Built Environment, rather than the engineering faculty at UCL. Something must have happened. But, you know, in my first, say, dozen, maybe 15 years after my 2 degrees in civil engineering, bachelor and PhD, I was working in a specialist services group at Atkins, and we were looking at developing and using what were then very advanced computational fluid dynamics models to solve industrial problems of fluid flow, heat transfer, mass transport. If we came across something that computers were too weak to handle at that time, we simplified the problem, right? We got to something where at least we could provide some thinking, some ways forward. Now, over the period of that time, computers got more powerful, so it became increasingly possible to do things which had previously been, I would say, impractical rather than impossible. We've only got a shortish session. I'll just give one more example. I've spent the last maybe 20 years or so, at least in part, sometimes most of my time, working towards the digital transformation of the construction sector. That's buildings and infrastructure. And I think a repeated theme in that is that technology is the easy bit in that. To really use digital techniques to their best, you have to change the processes you work through. But the hardest nut to crack of all is people. And about 2/3 of a digitally enabled change, my reckoning is getting people to understand that that they need to do things in new ways and hopefully lead them towards a situation where they want to do things in new ways.
Perfect, thank you. And Dr. Sivakumar.
Yeah, I think much like Tim, I couldn't think of impossible turning possible, but in the transport space, there have been some amazing changes over the recent times. I could mention a whole number of them. I could talk about smart highways, which have been in the news recently, and I won't go into it. I could talk about e-ride hailing and shared mobility services, which have become a reality. But what I'd like to maybe focus on is something much more core to all of those. The more integrated that transport and communications networks in particular have become, the more they have enabled a huge number of transformations. I mean, the operations of autonomous vehicles is a part of that. Smart traffic control would be a part of that because you have vehicle-to-vehicle and vehicle-to-infrastructure interactions. I could think of delivery drones that are coming up, loads of things that are current and in the pipeline. At the core, it's the integration of those two infrastructures that has made it possible. And to me, that's been a big part of the dramatic innovations.
Perfect, thank you. Professor Gardner.
Yep, so I was also hit with this question by Wilson about 10 minutes ago. But luckily, he also suggested quite a good answer for me. So this chap's going to go far. About 5 years ago, I was approached by the Alan Turing Institute and Lloyd's Register Foundation about a metal 3D printed bridge. And they said, you know something about structural engineering, can you help us with this? And at first, of course, it sounded, we'd all heard of 3D printing, but a bridge, is this possible? We started working with the company that was doing the building of the bridge in Amsterdam, and we started doing some testing, some simulations, and so on. And as time progressed, we got a good understanding of the bridge. We learned what was possible that we didn't know beforehand. And really what helped us sort of tackle the problem was going back to the fundamentals. You know, what are the things that we understand? What is the underlying material doing? Because that was the main difference between this bridge and conventionally produced bridges. During the testing, we did mechanical testing of the material. We've done a lot of this before. We got some pretty unexpected results. So we repeated the tests, got similarly the same results. And what it turned out is that the material was highly anisotropic, different properties in different directions because of the unique thermal history that the material had gone through during the 3D printing process. So we learnt about it, we understood it, and then we were able to simulate it. Eventually, we did full load testing on this bridge, up to and beyond the kind of loads it would see in practice. And the bridge has been in the center of Amsterdam and open to the public for the last 3 years. I visited it about a month ago. It is still there, still standing, and looking good.
Perfect, thank you. And then it's just not because I've learned it in my first ever lecture, Imperial, that 3D printed bridge. Anyway, so Professor Meng.
I think they have discussed some technology innovation in the past years, and as a kind of social scientist with a very short academic career, maybe I can share something from my personal experience. So when I got my PhD degree and came to the UK in 2016, I never thought I could get my professorship so quickly in such a young age. So I think in our career development, maybe we can aim high, not only in our research project, but also in the career path.
Perfect, thank you. Yeah, I think that's extremely fascinating, and I think it's very important for us to know that what we have achieved so far in our sector and how much that really affects everyday people's life. So let's go into the personal questions, I would like to call them. So, Professor Broad, as we all know, the main advancement in our industry is the digitalization of many processes in recent years, especially in the construction industries. So could you give us a bit of an insight on how digitalizing construction process or infrastructure will shape our city in the near future?
Yeah, I think you might have a couple of other questions for me. Could I take them all at once, please? Because
sure, absolutely, yes.
Everything is integrated in this world.
I'll finish asking all my questions then. So, we mentioned about sustainability already quite quickly. So, what is the most innovative sustainable technology out there that we should focus on as civil engineers or urban planners or anyone who are working in our industries? And also, I would like to ask you about something that's quite controversial in our industry and markets. So the integration of AI and big data, which we've trying to embrace in the past few years. And how do you see this in terms of the built environment?
Okay, I've got 8 points to make. I'll keep them brief, honest. And if any of the organizers are listening in. Yeah, I mean, the first thing on this, I think, is we need to get a much better understanding of what we already got. In a mature city like London, where we have so much infrastructure under the ground surface, we have a poor idea of what it is. Yeah, the London Underground celebrated its 150th anniversary just a small number of years ago. Records aren't there. We think we know, people think they know where most of it is, but they're not always right. The same goes for all other types of infrastructure, whether it's power infrastructure, gas, water, whatever, telecoms. Now, there are something like 120 organizations with a statutory freedom to dig the road up in London at any time. Right? This is within the boundary of the M25, so I'm stretching London a bit. Every now and again, they come, they dig a hole, they find somebody else's infrastructure. We haven't even got at the moment systems in place that can trap that, whether anonymously or not. So increasingly, we get a picture of what's there. So that's point one. Second point, and there is supposedly some order on this, non-digitally, I think we need constantly to be searching for new and better materials, right? Whether that's low or lower carbon concrete, whether that's better insulation. The typical insulation that's used in buildings just happens to be the worst for carbon emissions, etc. And whether it's plastic bridges, in fact, or other types of novel materials. The third part I've got here is that we are hopeless at thinking in lifetimes, right? We put up commercial buildings with a structural lifetime of 100 to 150 years. We tear them down after 40 or 50 years because they are out of fashion, right? We don't know what a lifetime is. I mean, we've had PFI and PPP schemes for the last 20, maybe 30 years. They tend to go up to about 30 years. That's not a lifetime, right? And yet we still look after Iron Bridge, perfectly viable pedestrian bridge in the West Midlands, which has been around for considerably longer. What is a lifetime? With buildings in the UK, things progress generally around the so-called RIBA plan of works, right? Royal Institute of British Architecture has a process map for construction. Nothing really extends beyond handover, right? I mean, the operational life is not only the most, the longest, it's also the most expensive, it's also the most carbon intensive. And also when we're thinking ahead, what climate are we developing for? Because the climate in 50 years' time and 100 years' time is not going to be what we've got now, right? That was 3. Fourth point, systems engineering and integration. Wouldn't that be nice? right? We're taking baby steps towards it, but we're nowhere close. I mean, a few years ago, the Infrastructure and Projects Authority launched a number of modules, I think it was 7, as guidance modules on how to start large projects. These included such things as procurement, governance, asset management, risk management, whatever. These were refreshed a couple of years ago, but only then did they think of adding one on systems integration, right? Why do we think of these? Why don't we think of these things? The next one I've got is we need to think of carbon in the same way that we do with costing finance, right? Finance, it's increasingly common to think in terms of CapEx and OpEx, capital cost and then operational cost. We need to think of carbon in the same way if we are to become more sustainable. What's the embedded carbon in putting something up? What's the operational carbon used in running it for many years? 6 point, only then is it really worth collecting live data from sensors. If you don't understand how a building is used, well, you can start collecting information on how people use it. Simple as that. It's what Rolls-Royce have been doing for donkey's years. It's what Formula One do to link reality with simulation, with earlier simulation. The last couple of points in here, and then we can look seriously at digital technologies that take us beyond the current general BIM model, for those who know that, building information models, now being extended into digital twins, which provide a performance model rather than just a geometrical model. And again, you can feed that with data from sensors to understand, for example, what energy a building is using and reduce the so-called energy gap between simulated energy in design and real energy used in practice. And then I think I've just got one note at the end. Just to note that over 80% of all the buildings and infrastructure we'll have by 2050, we've already got. So we need to think in terms of climate mitigation and not spend all our research, which is so easy to do, on new build, etc. And the second point on that is the future is always uncertain. With the advent of climate change, it becomes more uncertain. So we used to design a bridge, for example, to a return period, a 1 in 50-year flood event, a 1 in 100-year, 150. What do those mean now, right? We've stretched, I mean, we used to get these numbers, if you like, from extreme value statistics. Well, we've gone beyond the boundaries, and I think in those sorts of areas, AI just really won't help us. AI is good at interpolation, not so good at extrapolation, right? And the last point, I'll repeat what I said earlier, that technology, in all of this, technology is easy. Changing culture, changing behavior, getting people to want to do things that they haven't done before is really hard.
Thank you. I think my key takeaway from Professor Broyd is that the future city really affects everyone. It's not only the civil engineers, it's not only the architects or any planners. I think it's very key for everyone from different disciplines to work together.
Yeah, I mean, there's been a trend now for the past few decades, it shows no signs of abating, of people around the world moving from rural into urban areas. Now, urban areas require considerable infrastructure. A lot of the expansion of cities is reckoned to be, is forecast to be in what we might call the poor South. And it's cities that are currently 5 million turning into cities that are 15 million, et cetera, et cetera. And not only the balance, the sequencing of when you start to put infrastructure in, especially fixed infrastructure, before you've got the population that needs it, is absolutely vital. And remembering that these communities are often those that need substantial amounts of external aid.
I think that's extremely important. So let's move on. So Dr. Sivakumar, so we've always seen these films with, autonomous driving cars and all these fancy films. So I've always wondered, so how could that, instead of the AVs, autonomous driving cars, so how could that impact the daily travel behavior of everyone's life?
So, I mean, apart from the futuristic notion of autonomous vehicles, I think there have been a lot of different widespread impacts that have been in the popular news, and also the number of papers will also speak for it. I mean, academic journal papers. There's a lot of talk about impacts on potential safety. There's a bunch of studies that show they can improve safety because they are managed, controlled more efficiently than a human driver will. There are others that talk about what if that fails. So there's all sorts of pros and cons, both directions in terms of safety. There's discussions in terms of improving accessibility for a wider population in terms of people with disabilities, the young and the old being able to access the city more. There's also talk about efficiency of the use of resources, about how fewer cars can achieve the same number of trips, for instance. But what, for me, and there's other things. There's also things like reducing stress levels for what are traditionally highly stressful jobs, delivery truck drivers, heavy goods vehicle drivers, etc. And all of these have received a lot of press. But for me is really interesting to study, looking sort of forward into the future with autonomous vehicles, are probably two things. One is the value of time. It's a very economic principle, but the point is that the way we use travel time is projected to change dramatically, perhaps. We're not quite sure exactly. But based on those changes, it means there's going to be significant changes to people's choice of travel mode, where they go to, how much they travel, and these will have changes for patterns in terms of where people live, where they work. And so for me, that's a very interesting thing to look at, and also an equally difficult, challenging question to address. Perhaps the other thing when it comes to autonomous vehicles is something that popped into my head that popped right out again, I'm afraid. These thoughts come and go. But perhaps, so value of time is one of the biggest or most interesting things from my perspective.
Yeah, maybe we can discuss the second bit later.
Yeah, if it comes back to me, I'll
that's
go
all
back
right.
to it.
Yeah, there we go back. So I really think cutting travel time in London, especially as we all know, being late to your summits is always not the best thing in life, isn't it? So, Professor Gardner. So another thing we learned in lectures, 40% of carbon emissions come from the built environment and the construction sector. So how should we address or mitigate such figure from a structural engineering perspective in the climate emergency?
Yeah, so thank you for the question. And I should have said earlier, 下午好, and 我很高兴认识你们. Yeah, 40% is a big number, and it sort of makes the construction industry sound like, the bad boys. But if you consider the scale of construction, where we live, where we work, transport, energy, it's everywhere. Cities are everywhere around the world. There's a lot of materials needed to produce the scale of construction projects. So the 40% is a big number, and it's representative, really, of the fact that the construction industry is large scale. But it also means that we've got a lot of responsibility to improve things. We've got a big challenge, and I think, historically, people react well to challenges. And that's what the construction industry needs to do now at different levels. And it's about education, like at universities, through teaching and research. But of course, it's about industry practice, it's about governments, and so on. So what can we do? Well, I think a lot of it is about the materials that we build with. So traditionally, steel and concrete structures are most of our infrastructure. And you could say, right, let's look for replacements. I think that's part of it. I think steel and concrete are both fantastic construction materials. That's why we've been using them for so long. And I think there's scope to improve their sustainability credentials. There's different ways in which this can be done. I'm a structural engineer, and iron bridge was mentioned. I'm a steel man, so I liked iron bridge mentioned, though it's not a plastic bridge that I was playing with. It was a metal one. So, so as a structural engineer, we can think about the design side of it. We've got new tools emerging. AI is one such tool. Advanced computational simulations are other tools. We can design our structures better. We can use less material to achieve the same thing. This could save us 20%, 25%. There's also this challenge of cost. Cost is, of course, an absolutely dominant factor in the construction industry. And we don't always build structures that are the most efficient and most sustainable because of cost. A very simple example is you have a building. It might have 10 floors. The lower floors in the columns, you've got the most force. The top floors, you've got the least force. It's quite common to use the same section size over a number of floors and reduce the number of connections you need to make and the number of changes you need to make. That's not how you use the least material. And quite quickly, you can, and there's been some studies that have said roughly in structures about half of the material is used. Half, that's a massive potential for saving. But there is this balance with cost, time, expertise required to design more complicated structures. Looking at producing the materials, this is moving forward. Already in the UK, steel, which is my material, is produced at about 25% less carbon emissions than it was in 1990 levels. It's got a long way to go, but it is heading in the right direction. Decarbonization of the energy sector. A lot of material, a lot of steel can be reused and recycled. That's quite electricity intensive. We will benefit from the electricity grid being decarbonized. So these are examples of the kind of opportunities that we've got to make a big difference. But there's lots of work to be done, and there's lots of stakeholders that will be involved in this.
Perfect, thank you. And we've always mentioned that, carbon sustainability and, reducing our energy demand. So, so every nation's, at least, they need to act now to realize this climate emergency before it's too late. So, Professor Mun, could you recommend or comment on the most sustainable way to achieve these across the globe? Should every nation just cut carbon emissions, or is there a more effective way forward? Should they do something different, or should they collaborate together to engineer this better future?
Yes, for the climate mitigation targets, I think more than 170 countries have committed to achieve net zero in 2050, 2060, or a bit later. But at the city scale, not all the cities need to also achieve or reduce the carbon emissions as much as possible. But the decarbonization pathway should be very different, because the cities are at different local endowment and also industrial structure, and also the different economic development. So the decarbonization pathway at the city level should be designed according to their specific context. But at the city level, the cities, for the mature cities like London, we have quite mature and infrastructure. So we may consider measures such as the retrofitting measures and also to improve measures to improve the resilience. But for some cities in developing countries, we may use new materials and technologies to design maybe a more digitalized city, and also to focus on the sustainability. But for the decarbonization pathway, we should consider not only the mitigation, but also the adaptation. Because we may say increasing climate disaster in the future before we achieve net zero. So the future city design or the urbanization should consider the synergies between mitigation and adaptation in designing policies and new materials or the technology development.
Perfect, thank you. And Dr. Sivakumar.
If I can actually complete that
yeah,
thought.
please.
Yeah, so
Thank you.
it was good that I made a couple of notes just before we started because it reminded me. And so the second of the 2 points I was thinking of in terms of autonomy of vehicles is actually what autonomy of vehicles was originally kind of intended for, which is traffic flows. I think the most remarkable and widespread impacts of autonomy will ultimately be on traffic flows, both because autonomous vehicles are fundamentally connected, and connected means that they're connected to the infrastructure, connected to other vehicles, but also autonomy means that they're potentially controllable, which means that you could have dynamic pricing of road use, you could have smart traffic control, and that completely changes the way in which traffic flow is managed. So I think for me that's the other really widespread impact, and there's many threads to that.
Absolutely, yeah. So yeah, my question goes, so we talked about energy consumption from Professor Meng as well. So, I mean, we all live in a cost of living crisis and we have to pay a lot of bills for our energy. So what do you think is the biggest challenge in terms of energy conservation?
It's interesting you should ask me that because I'm much more a transport person, but over the 11 years or so, my work has spread into transport and energy. And initially, it was the electrification of transport, the implications of electrification in terms of electricity demand, energy demand, and so on. But recently, there's been a lot of use of the kind of research I do in energy demand modeling, per se, which is not necessarily the transport aspect of things, purely because my focus on transport is as a derived demand. The fact that travel is basically a derived demand, and energy is not that much different. It's also a derived demand. The demand for energy arises because people want to participate in a number of activities, and a number of those are energy-consuming activities, but also that there are goods and services that are being produced that people want to consume, and those are also energy-consuming activities. So when it comes to modeling the demand, that itself makes it challenging, but that basically means that when we say energy conservation, it's not a simple objective. It's a fairly multi-dimensional objective, because energy consumers are not just the requirement for heating and cooling and lighting. It's also your heavy equipment in hospitals, in industry, schools. So I think there's such a wide range of energy demand vectors that when we say energy conservation, we need to know where, when, how much energy is being conserved and what it means to conserve that energy. Are we suppressing that demand? Are we shifting it? So it's a very complex vector. And it's easy to think about it as a simple vector and thereby introduce several inequalities, perhaps. And if you talk about energy bills, that's a classic and easy to relate example. If we want, in the residential context, to develop energy conservation policies, it becomes really important to also consider who is impacted by those policies and how much and how and where, because if we don't do that, then the policies could have the inadvertent impact of segregation, unequal impacts on different segments of the population, and so on. So I think the most interesting thing in energy demand modeling, the methods are there. You can produce outputs that help towards designing the right conservation policies, etc. But do we look at that energy demand in all its heterogeneity? And therefore, can we assess the right policies that can be fair and just in that energy conservation process? That's the big challenge.
Perfect. Well, I guess in the future, maybe I'll pay less for that. So, Professor Gardner, let's go back to the AI topic. So as we all know, we mentioned additive manufacturing, just like 3D printing requires extremely complex calculation to make sure the route and all the process is in place. So is there any possible ways of combining AI with 3D printing?
Yeah, I think there are. So I got involved in 3D printing for construction a few years ago, and we're really at the very early stages of understanding the potential. Construction is big, and that brings certain challenges. So I think the use of 3D printing or additive manufacturing in construction is going to be targeted. And some of the work that we've done, for example, has shown that by taking existing material and like a steel column or a steel beam and adding a relatively small amount of material but in exactly the right place, which is what 3D printing gives you the potential to do, you can get disproportionate increases in capacity. And I'll give you a simple example. We've looked at strengthening I-section columns. I-section columns are everywhere. By adding just 2% extra material, we had a 20% increase in capacity. That means that the efficiency of the added material is 10 times that of the underlying material. That's good bang for your buck. It can be used for new construction, but also strengthening existing structures. And, you know, as we've heard, a lot of the infrastructure of the future is what we've already got. So we've got to look after it, we've got to strengthen it, and so on. Now, AI is a new tool, and it's got potential applications in structural engineering for sure. We've started looking at it briefly, and an example of how we've started using it is 3D printing can have defects in it. We don't like defects, and so we need to be able to predict them, detect them, and eliminate them. By linking the parameters that you can measure during the production of something through 3D printing, voltage, current, gas flow, all of these kind of things, linking that to the quality of the final product through AI and machine learning, you can actually learn a lot about the process. You can predict where defects are, and you can eliminate them. And this is just one example. I think, you know, AI more broadly can speed things up dramatically. Sometimes barriers to doing things in a more sophisticated way is time. It takes too long to run endless computational models. AI can be used in conjunction with computational models to enhance dramatically the efficiency.
I agree, yeah. So as we want quite short on time, so the last question goes to Professor Moon. So could you shed some light on the collaboration between China and UK in energy conservation and emission reduction, and how do these countries work together to combat this energy crisis?
Thank you. Yeah, I think China and the UK have a long history of the collaboration in climate-related topics. Last year, very recently, I think China and the UK have a joint program related to the science, technology, and innovation. So this document highlights many specific technologies which can be collaborated across countries. And for the low carbon technologies, we have a huge opportunity in the collaboration for the technology with low readiness for the future demonstration, because the UK have maybe relatively better technology innovation environment, but China has a better manufacturer supply chain. For some technology, carbon capture and storage, and also the hydrogen research center, I think we can see many increasing research projects. Last year, China and the EU also have a EU-China flagship research project, and also the China-UK research projects will be maybe anticipated to come out soon. So it's research projects, but for the challenges in front, we have different challenges across sectors in energy sector and building sectors. But we can share the experience regarding the policy design and also the energy efficiency measures.
Perfect, thank you. And obviously, I would love to ask another question, but we're very short on time. But I think to wrap up, we stopped at the tone of collaboration. I think the same, it's very similar to our China-UK Technology Summit. The point of us all congregating right here is to share our insightful information and try to possibly create a bit more collaboration between our two countries in terms of technologies, and maybe I really strongly agree that in the future that we will shape the better future city. So thank you so much for the discussion. Thank you all. Thank you.
Wait. Thank you to all of the speakers. Yeah, thank you very much. Now let's zoom down into everyday people's health. Because now it's time for our second forum, Future Life Science, discussing gene therapy, smart healthcare, and new drugs. So we have a new set of amazing guests, and moderating the second panel is Dr. Zhang Jingkun. So please, everybody, give him a warm round of applause, and welcome all of our guests on stage. Thank you. Please. Dr. Zhang Jingkun.
Ready? Ready? Yeah. Okay. Is it working? Yeah. Good afternoon, distinguished speakers and guests. Welcome to the Future Life Science panel discussion. Before we start this panel, I'd like to first give special thanks to Professor Thomas Lindau for his inspirational speech today. We are very honored to have him to be here with us today. So my name is Jingkun Zhang. I'm a PhD graduate from the Francis Crick Institute. I will soon be joining Professor Jennifer Doudna's lab at UC Berkeley to study CRISPR. So the past decade has witnessed a booming of biotech and healthcare innovations. Just to name a few key phrases, CRISPR gene editing, gene therapy, cell therapy, immunotherapy, synthetic biology, precision medicine, AI prediction of protein structures, which we'll hear more about in the last AI panel today, mRNA technology, which led to a Nobel Prize this year. Many of these breakthroughs were once thought impossible, but right now they're not only possible, but actively being reimagined. And this journey of reimagination isn't confined to just one sector. It is contributed by many players in the life science ecosystem. We have academic research labs, big pharmas, biotech startups, and life science consultancies, and many other players. And today, we have a very nice panel that represents a very wide part of this spectrum. We have Professor Hirag Patra from Academic Research Lab, Dr. Du from a big pharma, Dr. Peiling Li from a life science consulting firm, and Mr. Jiang Shan from a biotech startup. We're here to hear about their experiences, and they will talk about the challenges they're facing, and they will talk about the future they envision. So before we start, I'd like to have each of the panelists briefly introduce themselves. Maybe let's start with Mr. Jiang Shan first, please.
Okay, I'm Sean from Alurus Bio. So, well, you can see I did part of my undergrad in University of Edinburgh, and then dropped out and started my own company, Aluris. So I started in China. We are a synthetic biology company focusing more on high throughput screening, protein engineering, and yeah, and recently we just started another one back in the UK. Well, it's registered in Scotland, but our lab is it's actually just near to the White City campus in Imperial. So my background is more in synthetic biology, system biology, and microbiology. So it's not that therapeutic compared to the others anyway.
Dr. Li.
Hi everyone, very nice to meet you. Firstly, thank you to the organizers for organizing this very exciting event. I am Pui, and I am currently a life science specialist at LEK Consulting, which is a life sciences consulting firm. So a bit about my background. I did my PhD at the Francis Crick Institute where I met Jing Kun. It was in cancer immunology. During my PhD, I became interested in starting startups. I tried to start one, but we didn't have the knowledge domain because I did it with a bunch of other undergrads and master students. Then I became interested in understanding how do investors decide which startups to invest in. So I did some venture capital internships and eventually decided that life science consulting would be a good place to start my career because you get exposure to a wide range of very exciting innovations, learning how to help companies commercialize their products. And I look forward to sharing with you more about my experiences later.
Dr. Du, please.
Hello, everyone. I'm Yue Du. So firstly, thank you very much for having me on the panel today. So I'm working as a senior scientist at the moment at AstraZeneca, based in Cambridge. So I'm specifically on developing gene therapy for rare diseases in AstraZeneca. So before joining AstraZeneca, I was in Oxford for postdoc training on gene therapy as well. And I started my journey in the UK in Edinburgh on gene editing biotechnology. So it's really nice to be here again, and hopefully we will have a nice, fruitful discussions today.
Hi. First of all, thank you for inviting me in this panel. My career was not as smooth as like them. So I'm now Professor of Precision Nanosystems and Advanced Therapeutics at UCL. And I'm a biochemist by training. Before starting my PhD, I changed almost 3 continents, 6 countries, probably 5 labs before starting my PhD at the time, because I wanted to work on nanoscience, and it's not, at the time, back in that time, not many labs working with nanoscience and in the field of life science. So my main research area is in nanomedicine, and other part of application is in regenerative medicine. So hopefully we'll enjoy this panel discussion.
Thank you all for the introduction. So the topic of today's summit is called Reimagining the Impossible. So first, I'd like to start with the possibles. Maybe let's start with Dr. Du, please. Can you discuss some of the recent breakthroughs in gene therapy? And what do you find very exciting, particularly?
All right. Thank you very much for the question. So I want to start with a quick show of hands. Have anyone heard of gene therapy? Great. You are reading Economics and the Wall Street Journal every day. Yeah, so gene therapy is a very new modality for especially genetic diseases. As Professor Linda gave a very nice summarize about his story and his scientific story about DNA, fragility, and repair. Yes, everyone is a book, so we are a book. We have DNA, we have RNA, we have protein. So for our whole life, we are coding and decoding by ourselves, and the coding is for diseases. So once the DNA is keeping mutated, and once the DNA has some problem, our body has to repair it. That's where gene therapy is coming from. So gene therapy recently is really blooming, flourishing, and accelerating all over the world. So if you ask me about the breakthrough, the status of gene therapy, the word is surging. So so far, we have in vivo gene therapy. We have in total 7 in vivo gene therapy. 2 of them have been withdrawn from the market, but we have 5 FDA-approved gene therapy. So FDA is the United States federal government administration for food and drug. So for these 5 in vivo gene therapy approved by FDA, from this year, actually, we have 2 approved. One is for hemophilia B. The other one is for Duchenne muscular dystrophy. It's a really breakthrough this year. So if you see the whole history of gene therapy, the first one was actually approved in 2017. In just 6 years, we have 6 approved gene therapy in clinics already. So I think this is a really breakthrough, and gene therapy is really where we have our hope is. So for the next, if you want to know more about for the next questions, I would like to give more sharing about gene therapy and the challenges and the future, etc. But if you ask me the current status of gene therapy, yes, it's surging.
Just a quick follow-up on that. So what kind of diseases can be targeted by gene therapy?
Yeah. So as I mentioned, gene therapy is basically targeting for rare disease at the moment mainly. That's the reason is because DNA is keeping mutating and our body is keeping repair DNA, but still something going wrong. So if you have some genes are wrong, then your body cannot fix it. It can turn to tumors, for example. So oncology is actually our next step for gene therapy. But for now, it's mainly for rare diseases.
And are these diseases mostly caused by loss of function mutations?
They can be. One loss of function can be one. So if you don't have any functional genes or lose a loci of genes from when you were born, then you need a therapy to deliver the gene of functional gene. But as you mentioned, the CRISPR-Cas9, if some genes are going wrong and you have some mutations, then you can simply put the CRISPR, which is like a scissor and a cutter into it, and also you can replace the gene which is wrong.
Thank you. Next, I want to ask Professor Patra. Can you briefly introduce the field of nanomedicine and what advancements do you find particularly exciting?
Yeah, thank you. So nanomedicines is basically the use of nanotechnology in therapeutic purpose. However, before starting that, why a scale become a science and a technology? Like we don't have a kilo science or kilo technology. We don't have a mega science or mega technology. We don't have a pico science. And suddenly how nano become a science and a technology? And to answer this precisely, if you see the bulk scale material, whatever it is, let's say it has some properties, and if you just cut it half, it will show you the same properties. Now, if you keep cutting those half, and then you will come up to a point when you might have a different kind of properties. Let's say if you chop this gold up to the nanoscale, then this will no longer be glittering, rather than it will be red in color. And that is why it is so important that when things come to a nanoscale, the bulk properties, you can get some new properties other than the bulk properties. And that is why it is so important in the technology and scientific point of view. Now, if you go below that, let's say in the pico level, so then you will find protons and electrons and neutrons, and they have the, again, equal property. So you have a kind of emerging properties at the nanoscale, and then you will have, again, the similar kind of properties. If you split me into atoms and then to the subatomic particles, you'll get one bucket of maybe electron, one bucket of proton, half a bucket of neutron. Similarly, these maybe the phone, the table, everything. But if you come to the nanoscale, it will give you some new emerging properties, and that is why it is so important. Now, in the biological context, the why nanotechnology is so important is if you consider the smallest molecule, let's say glucose or ATP, those are 1 nanometer. And now if you look at the most primitive form of life, let's say virus, it is 100 nanometer. So just imagine whatever happening inside your body from 1 nanometer to the 100 nanometer. So if you have anything at that scale, if you can make yourself at the nanoscale, you can literally see what is happening within a cell and within our biological system. And now, in terms of medicine, we haven't used that much in terms of medicine. It's just the tip of the iceberg that we are seeing at this moment. There are 100 FDA-approved nanomedicines out there, but still, it's just a fraction of it. Now, COVID, in one way or another, helped us to accelerate this fact, and that is largely because of the 2 nanovaccines made by Pfizer and the Moderna. So whoever has taken those 2 vaccines are the nanomedicines that you have already taken. And that actually, I think the last breakthrough that you are asking me about, the latest breakthrough of nanomedicine is these 2. There are plenty of them will be coming in terms of DNA delivery and nucleic acid delivery as well. And they are under clinical trial and in the regulatory approval process.
Thank you. So you mentioned there are about 100 FDA-approved nanomedicines. And also you suggest that nanotechnology can be used for delivery. I'm curious, what diseases are targeted by that 100 FDA-approved medicines?
Yeah, it's a very good question. So whenever a new technology comes, the ground for us to test, as you just mentioned, is cancer. Because it is so devastating, and we are still far from the cure. So most of these technologies and the use of nanotechnology is still on the side of the drug delivery and drug delivery, especially to the cancer. And the precise reason is that, like, you can have a very nice, fantastic molecule. Eventually, I had one discussion with one of the senior scientists at AstraZeneca, and he told me that we don't have shortage of library of drugs. We have plenty of drugs, but the problem is, how can you take this drug to the appropriate place is a challenge. But we are still using the same pharmacological approach to have that your blood API level will be raised up to the point that it will hit the organ. And so let's say if you are trying to, we just need to have the correct kind of transport vehicle to take the drug to the particular place in all sort of diseases.
Thank you. I'll come back to the collaboration between academic labs and AstraZeneca later. So I want to move to Dr. Li. Can you introduce your daily roles at LEK and how your company help life science ventures and academic labs with their innovations?
Yep, certainly. So at LEK Consulting, we have a range of clients that will come to us with a question. And this could be a strategy question or an investment question. So like, for example, big pharma companies or even like biotechs could come to us and say, oh, we have this very exciting CRISPR technology. It can deliver drugs to a certain place. And what indications should we pursue? Should we do like cancer therapeutics? If we do, what kind of cancer? Is it lung cancer, pancreatic cancer, breast cancer? So what we do is we would conduct a series of market research. We talk to key opinion leaders like physicians, commercial experts, other competitor pharmaceutical companies to see what's the biggest trend in the industry. We also look at the science. We do a lot of literature research reading so that we know what's the best what's the market looking like, what's the most trendy area, what kind of indication would help them get the most maximized revenues, and what would address the biggest unmet need in the current disease landscape. Then with regards to investment opportunities, we often have like VCs or private equity funds who come to us and say, oh, we want to change our portfolio strategy, we want to buy or sell a certain company. So could you help us to look at whether this would be a good investment decision? And what we do is we look at certain companies that they're interested in, see what's the historical revenues looking like, do we think that the market is growing, what are the customers thinking about this company, what do we think will be the forecasted revenues in the future. Then this would help those private investors think about what is the right valuation for this company. So there's a lot of different questions that our clients could come to us. These days, ESG is a very big thing that pharma companies are looking into. There's also all these talks about trying to cut costs, ensure that your supply chain can be managed. During COVID, we saw that global supply chain was a really big issue. So a lot of companies do come to us with these kind of questions. And because we serve a lot of clients, we know what is the market trend, we could advise them. And of course, we keep all the information confidential. Like, we serve a lot of clients, but we don't tell them which specific company is doing what. We just share with them what's the market looking at, and this would help the clients stay competitive.
Thank you. So you offer mostly strategic, high-level advice. But if I failed my experiments, I want advice on my experiments. Can you help me?
Well, I used to be a PhD student too, and yeah, if your experiments fail, then I suppose what we usually do is we think of a very structured problem-solving process. If your experiment fails, then we could solve it in various ways. Like, firstly, should we think of a different technology? Secondly, could it be because you don't have the right control in place? Thirdly, should you be trying something else? So we haven't had people coming to us with those questions. Your PI will be answering those questions for you. But yeah, I think we are pretty flexible, because with the consulting mindset and way of thinking, usually you would be able to solve questions. If you don't have the right domain knowledge, we would always reach out to our experts. We have a network of experts from all the different geographies, because we have officers in APAC, in the US, in Europe, and we often work with our colleagues from the different offices. So like, a pharma company could come to us and say, oh, we want to launch this drug, and we want to target different continents. Could you help us? And we will put together a team of consulting staff from the different offices, and this would help us leverage all the different domain expertise from the different geographies.
Thank you. Next, I want to move to Mr. Jian. So, Mr. Jian, you had a very unique experience. You dropped out your university and to start a biotech company. Can you tell us why you did that, and maybe share with us your experience in your entrepreneurial journey, please?
Okay, well, it's not a Bill Gates style story, so it's actually a more like pandemic story. So I started my undergrad in 2019, and then of course in the early 2020, the school stopped. We were sent back to China, and during that time I was doing internship in my friend's company. But because me and the founder we are really close friends, so I'm actually just sit there all day and reading all the posts, but never do any experiment or work. So my friend came back as well. He just finished his PhD in Paris. And then we had a really short discussion about like 10 minutes on what kind of technology we have, and what kind of market or what kind of company we want to build. Then we just kick off. And then I take a gap year from the uni, and then during this time we got like, if we got into pounds, it's about like several million pounds of investment. And then the school sent an email at the end of summer saying, are you coming back? I was like, nah, I'm not going back to do like courses like molecular biology of the plants. That's like killing me in some way. So dropouts are quite a normal trend from the experience at that time. So it's not like, yeah, I'm a genius at dropout. I'm not a genius anyway. So but I think I highly not recommend people to do it. I started my synthetic biology journey quite early in my high school, and then during that time I won some world champion in synthetic biology field. So starting a company, the skills, I mean the technology side is not that hard for me, and I would say synthetic biology or industrial biology or whatever you call it, the non-healthcare related biology side is quite different from healthcare, because in healthcare you got loads of regulation, FDA, EMA, or back in China, NMPA, or all these agencies together. But in our field, it's like we don't have any regulation at all. We can do anything you want to design, only like nothing poison and obey the law. That's it. So we do not need that much like training in a very niche and a very niche scientific way. So I would say the industry is really different from the usual like biotech and pharma relation. So our industry sometime, or our business, take us to a place we never thought of, like pig farming, chicken farming, fish farming, or like a dyeing industry for clothes, or like a battery recycle, or like bioremediation of a certain chemical factory. So it's really unique to see the back scene of our daily life, which are actually built by all this industry. And it's more exciting to see that we can actually use our solution, or together with our partner, to like help them to get into a more like bioprocessing way of doing this. So it's quite exciting, and yeah, and I think I'll share a bit more about some dreadful moments a bit later, but yeah, it's fun.
A bit later? Maybe you can start now. I mean, what you did is certainly requires a lot of courage. Yeah, if you want to share it now, you can do it.
Yeah. So like, okay, it's more like in general startup stuff. So when we enter this field without regulation, someone in one side is fun. We don't need to all the paperwork and all the necessary paperwork. But on the other side is that there isn't an actual paradigm we can follow. So for example, a professor from a lab find a potential drug. We all know how the process goes, and we all know when the venture capital come in, incubator came in, big pharma comes in, regulator come in, and how the sales should be, who the target customer are. And for us, it's like, okay, we don't need this, but like we don't know where are they. So we are not sure like which market we should go into. How are the budgets? How is our customers' expectation? So some of them are with some like bio background. They know like, okay, the discovery might take about like a year or two. Some of them are willing you to improve an enzyme from 30 degrees Celsius working temperature to 70 in like 3 months. So it's very different to, and it's very hard to like find all the knowledge linking together. And then later on, it's like, okay, do you follow like IT industry, their way of like organizing, or like product development, or do you follow the pharma industry, or do you follow the chemical engineering industry? It's all like we all, because it's an interdisciplinary subject, or the industry it is, we have to learn or try to use some prior knowledge experience from other industry and grab them like piece by piece together, and usually it fails because we don't have our own way. The biggest company in our field only exists for about like 15 years, and another like bigger one just filed for bankruptcy. So it's a very uncertain path. It's like uncertain market. Everything is uncertain, and even for investors, it's a new market. They always talk about it, but in terms of investing, they all very confused with like what's going on. How do I do the evaluation for the company? So that's also it's loads of unknown on the way, and loads of them are unknown rather than the known unknown. So it's like even worse, I would say. Yeah.
Thank you. Thank you for talking about the challenges. Also like to hear about challenges that the other panelists are facing. So Dr. Du, what are the primary challenges in translating gene therapy research into viable treatments for patients right now?
Yeah, that's a really big and complex question. So challenges are there. We have a lot of challenges in different points. So let's think about gene therapy or other chemical medicine or protein medicine. As a routine, we can develop a drug, for example, in 12 to 15 years. In particular, we develop gene therapy using $2 to $6 billion for the whole pipeline until going into the patients. And for gene therapy, the biggest challenge is the population is limited. This is one. Because, for example, as I mentioned, currently gene therapy is mostly for rare disease. So what's rare disease? So the definition globally is if the current population of some diseases is like 1 in 200 million, that's rare disease. So if you mention Zolgensma, which is a very typical gene therapy approved in 2019 by Novartis. This is for muscular atrophy. Zolgensma has dosed more than 1,400 patients, and one single dose is $2 million, more than $2 million. That's a huge money for one-time treatment. So this leads us to the second challenge is it's very expensive. Why is expensive? If we see the whole pipeline of the drug development from research, from solid science, from translational proof of concept study development, from any strategic design, from clinical trials, to commercialization, to market, we have a lot of difficulties to reduce the cost. So the cost there, especially, for example, manufacturing, because gene therapy is basically a virus therapy. We are living with virus, but some virus can be engineered to be safe to human beings. So that's the delivery vector for gene therapy. For example, we are talking about adeno-associated virus like AAV. We are talking about LNP. We are talking about different delivery system. But all of them, the manufacturing itself is very expensive. And we are also talking about delivery. The tropism of delivery. As we know, the chemical medicine or any protein delivery, we take a tablet, or we get a jab. The drug can go all the body of yourself. But for gene therapy, the charming point of gene therapy is that we can use one-time treatment, but also we can deliver the gene of interest by the vector into the specific cell we are interested in. So it means that we don't need to target the whole body of gene therapy. In this way, we can save some money by one-time treatment into the cells we are interested. But also, we have to make it very specific and very safe to deliver the therapeutic protein into the cells we want to deliver to. And also another thing is about we have talked about the manufacturing, the safety, and another thing is commercialization. So a lot of biotechs need money. They need money to survive. They need money to study, to do the solid science, to do the discovery. And then acquisition may come. So we kind of talk about the collaboration, bridging the academia, biopharma, and the startup. And also, basically, this panel is really good. We link different parts of different parties of the whole sector. Et cetera, is a lot of challenges, but as I mentioned, the challenges are there, but it's also an opportunity. The opportunity is which allows us to put patients first and also to develop really useful and safe drugs to patients that are with unmet need in clinics at the moment.
Thank you, Dr. Du. Professor Patra, could you briefly comment on what challenges you're facing in the lab?
Yeah, the main challenge is kind of standardization. Like in one hand, when you are thinking about, oh, we are getting new properties at the nano scale, that's good. But then, if you have, let's say, a 10 nanometer cold nanoparticle can be red in color, but when you come to the 15 nanometer nanoparticles, that is blue in color. So just imagine, if you tune the size, you can tune the properties as well. So we need to have kind of standardization procedures. So as you mentioned about the solid lipid nanoparticle that has been used for the vaccination as well, which size is the best one? Is it the smallest one or the largest one? Which is the optimum size? You know, these work for someone, but might not be work for someone else. So the first challenge is the standardization. That we need to have particular size and shape and surface charge is equal and optimized for a particular therapeutic procedure. Otherwise, if you keep changing the size, you might get a different kind of properties. The second thing is the complexity in manufacturing. So getting regular size nanoparticles at that precise scale is a huge task and challenge. So the complex the procedures are, it's difficult to control the reproducibility and translate it to the industrial setup. And lastly, we are yet to know the long-term impact, like if something has been mistargeted, what will happen down the line. Now, we are lucky that we have got 2 nanovaccines, but these vaccines are kind of disruptive innovation. We haven't tested for 10 years. We don't know down the line what might have the consequences. We don't have the time to test those ones. So the last thing is like we need to have kind of understand what are the long-term consequences. So these are 3 main challenges.
Thank you. Dr. Li, so could you give us some specific examples on how you help laboratories or biotech ventures for pushing a new therapy into the market?
So maybe I can share about one of my most recent projects. So like when we often think about drug, like the commercialization of scientific innovations into the market, we always talk about biotech, big pharmas, but there's also another sector of the market which is called the pharma services. So these are like the CDMOs, the contract development and manufacturing organizations who would often help big pharmas manufacture their products. And this could be because like the economies of scale problem. So for example, gene therapy, in order to manufacture this, sometimes it can be very expensive just to get trained personnel in. And if a pharma company just have only a few indications and they need to manufacture this just for clinical trials in small amount, then it wouldn't make sense for them to make a big investment. So what they would do is they would engage all these CDMOs to come in. And in one of my most recent projects, we were trying to understand what are the market trends in the CDMO. So drugs can come in many different dosage forms, like you have the solids, the semi-solids, the liquids. And I think now the trend is going towards, I think nanoparticle, nano delivery is a very big thing because you want drugs that can be delivered to very specific areas with minimal side effects. Yeah, so what we help them to do is to understand, and we try our best to accurately predict what could be the market growth in certain sectors, which dosage forms are the most attractive. And eventually, our final output was there to help a PE firm decide whether they should buy or sell the company. So that is an example of a project which we have done. I think that if I think more broadly about therapeutics, one of the key challenges now is probably trying to find a very common disease mechanism that can be applicable across indications. In cancer therapeutics, we've been thinking a lot about personalized therapy, but like what the speakers have mentioned earlier, this can be very expensive. I think that like cancer checkpoint, immune checkpoint inhibitors, those are very exciting concepts because it's applicable to a lot of patients, and targeting many patients also means that the therapies comes to patients really quickly, rather than having to wait for so many biotechs to come up with new drugs just to help so many different types of diseases. So I think that is very exciting. And very recently, we have been hearing in the news about how Novo Nordisk, which developed one of the drugs for diabetes, the semaglutide, they got the approval for diabetes, and they have been trying it. There's some interest to try it in obesity trials, in chronic kidney disease, because a lot of these metabolic diseases are interlinked. And I think the news came out a few days ago. It was very exciting because they could stop the trials in kidney diseases earlier since they saw some good efficacy. So I'm really excited to see how we could slowly, well, I think it is still important to have personalized therapies for patients with rare diseases, but at the same time, for those diseases that share a common mechanism of action, it will be really exciting to see what are the new drugs that are going to come up soon.
Thank you. Due to time constraints, I think I will ask one or two general questions to all of the speakers. My first one is, how can we better translate academic research into real-world applications? Maybe let's start with Mr. Jiang, please.
Well, from the synthetic biology or industrial biology academia translation, I think it's important for either the PI itself or the PhD student appointed by the PI to run the project, or just a PhD student that want to continue in academia, to actually get into the market and do a very thorough market research is very important. There isn't any, well, in our field, I don't think there is a really technology burden, something you only have for yourself. So it's important to understand how the entire market, from the upstream supplier to the downstream customer, and who is paying for what, and how the investment, how are the costs, various steps, they must be known by the founder itself. And then they can decide to what kind of startup or business model, whatever they want to be. So because I mean, it's quite general startup tips, but what I've seen in loads of academia, translational, people just ignore it because they think I got a super technology can take them all, but it's not. Technology is not playing that kind of crucial role in this. It's more about the strategy, I would say, and the understanding, of course. Yeah.
Dr. Li?
So I think it is important to keep an open mind. I believe most of the audience are PhD students or like undergrad students or postdocs. And it's very good that you are here today to listen to all of the very interesting panels. So when I was doing my PhD, my first 2 years were just doing lab work. I knew nothing about commercialization, translation, business. And it was only when a friend brought me to join some career fair, I started learning more about all these things. I think it is quite exciting now. There's a wealth of free information out there. You can attend talks by different accelerators, read news, follow the right people on LinkedIn who share the very exciting news, join accelerators. I think like even Deep Science Ventures, they are starting a new PhD program where students would be doing their academic research, but at the same time, always be thinking how they can commercialize their research. All of these opportunities are really exciting, and just keeping an open mind. You never know when you would have the right research output that could actually turn into a very exciting commercial strategy. And like at the Francis Crick Institute, we have the translation team. They organize a lot of events like KQ Lab, PALS. I think members of the public, if you're not in the Crick, you can still apply to such programs. So just keep a lookout to see what other universities are organizing, any events, attend them, and just broaden your knowledge.
Dr. Du, please.
I can share in 3 words. Good science, no, 3 phase. Good science, communication platform. Good science is for really, like Dr. Lee mentioned, think big, keep open-minded when you do your research. So when you do research, you design experiments, always think whether this will be useful and efficient to be translated into clinics. I can share that for when I was in Oxford, so we were developing proof of concept study for rare disease cystic fibrosis. So from zero, at the beginning, we believe that we can translate, we can make a drug from our lab. So in the end, we follow this way, and then we finally spinned out we outsourced this cystic fibrosis pipeline to Birmingham last year. So this is a really achievement, but it's not only about solid science, it's about the second and the third points I mentioned. The second one is platform. You really need a good platform, like in Oxford, you have an Oxford Innovation Center. In Cambridge, you have Innovation Center, etc. in other universities. You have to keep communication wisdom, have communication wisdom, and to fill the gap that you don't realize you have actually. So it's a collaboration. So I think academia do a lot of good, solid science. Maybe the biotech and the biopharma can do a lot of solid, very strong discovery and translation, and also the clinical trials development and the commercialization. I think when all the parts fall together, it will be a good drug.
Professor Patra.
Honestly, I still think that there is a vacuum in this place. When you are working in the lab trying to develop something and then you are trying to translate, I cannot find a single person or a student who is expert in translation. We don't train students in translation. So we don't have a kind of PhD program in translation. So I honestly believe there is still a gap. So I applied for a few patents, and then they asked me to do market survey. I don't have the expertise and the capacity. Even if I improvise myself to do something, go to the and check the reports in the internet, but that also be in the novice level. I don't have the real expertise to check how good and how bad is the market. So in my opinion, we have the knowledge as well as the skill gap down there. The second thing that I also honestly believe that even if you have something that you have discovered, let's say I'm doing research on something and a few years later I got some exciting data. And then if I'm going for translation and to the patent office, even if you have a dedicated patent office in your university, then you have to hold this one until and unless for publication, until and unless that has been filed for patent. And then you cannot apply for grant, you cannot publish your result, and then how you can run your laboratory during that time of period. So we tend to, if it is, quickly going for a translation, someone is showing interest in translation, okay, good enough, you take and then proceed. Otherwise, I don't think that there is still a smooth path for translation in the academic environment.
Thank you. I think our time is up. I'll pass the stage to our host Total, but before that, let's give a round of applause to our distinguished speakers, please.
Thank you very much.
Wait.
All right, guys, we'll see you back here in 1 hour, okay? So we have some fantastic panels coming up in 1 hour. So we have the Future Venture and the AI panel beginning in 1 hour. So please see you at 3:30 p.m., okay? Hello, hello, hello. My friends, we're about to begin again, so please take your seats, relax. 大家可以坐，马上就开始。So we're about to begin. Everybody please have a seat, yeah. Welcome, welcome, welcome.
Could you ask all this panel for future ventures to be seated? Sure.
Okay, so could our future venture panelists please come on stage? Come up on stage, have a seat. The future venture panelists, yeah, we're about to begin. Welcome, welcome, welcome. Okay. So welcome back, ladies and gentlemen, welcome back. Hi, have a seat, yeah. So next up, we will dissect the trends, challenges, and opportunities that will define the entrepreneurial landscape in the years to come. It's time for our third forum, Future Venture, discussing tech innovation and lean startup. Are we ready? Yeah, okay. All right, guys, we're about to begin. Moderator. Okay. Where is Miss Yuki Yuan? Hi guys, welcome back, welcome back. So we're just waiting on our moderator and we're going to begin the third forum. So this one will dissect the trends, challenges, and opportunities that will define the entrepreneurial landscape in the years to come. So this third forum is called Future Venture, discussing tech innovation and lean startup. but we've lost our moderator, so she'll be with us very shortly. And she is the very talented and beautiful Miss Yuki Yuan. Please give her a round of applause. Woo-woo! And she's going to introduce all the fantastic guests. Thank you.
We also have Professor Robert Kosofsky. Total. Professor, 还有一个。
Still waiting for Professor Robert. Robert. So we're still waiting.
Hi everyone, welcome back. I'm Yuki, and I'm currently a PhD candidate at Imperial College Business School. And it's a great pleasure to welcome you to this hopefully thought-provoking panel discussion on the future of venture. In this dynamic conversation, we've gathered some of the brightest minds in business and innovation to explore the entrepreneurial landscape of tomorrow. Without further ado, let me introduce our esteemed panelists. First, we have Professor Erko Chiu, Chair in Technology Venturing and Entrepreneurship at Imperial College Business School. Erko is the first person I wanted to invite into this panel, not because that he's my doctoral supervisor, and not because that his research work has been cited over 55,000 times. It is because Erko is world-renowned for his work in entrepreneurship, and he's an expert of entrepreneurial ecosystem in Asia. He's currently engaged in two exciting initiatives: the Ant Resilience Project, exploring entrepreneurial resilience in the face of the COVID-19 pandemic, and the Wiki Acceleration Lab, a collaboration between Imperial College Business School and the Royal College of Arts, focusing on wiki problems, deep tech, and moonshot acceleration. Next, we have Professor Robert Kosofsky, Head of Department of Finance and Professor of Finance at Imperial College Business School. And prior to this role, he held many roles in the private sector as the head of quantitative research at a $30 billion asset management firm, and also as specialist advisor to the UK House of Lords, and as expert technical consultant for the International Monetary Fund. Robert's research interests are in the area of assets and risk management, as well as machine learning and hedge funds. We also have Mr. John McLean, OBE, Chair of China-UK Business Development Center, joining us as an expert in China and UK trade relations. In 1999, John started his China relationship by setting up a business in Shanghai manufacturing textile, which in turn was sold through retail outlets in China. And since then, he has been an investor and chair of other Chinese businesses while actively promoting collaboration and trade between the two countries. In 2014, he was honored with an OBE in recognition of his service for the promotion of trade and development of the civil society in China. And last but not least, we also have Ms. Jill Tan. Jill is a social entrepreneur and a community builder. She's a co-founder of Ladies Protect, a social enterprise focusing on changing the status quo and propose gender diversity and inclusion in STEM industry through offering women digital skill education, career opportunities, and community network. Ladies Protect connects more than 70,000 members across all social media in Greater China, and now has presence in 16 cities, including Singapore, London, Kuala Lumpur. And recently, she was selected as the top 25 finalists for the 2022 We Empower UN SDG Challenge. Great, that's all of our panelists. And now we have our first question for Professor Erko Chiu. Professor, you've led research projects with important implications for government and policy agencies. How do governmental policies influence tech venturing? And could you please identify specific policies that you believe can really boost entrepreneurship?
Okay, thank you, Yuki. And I can confirm that Yuki truly is an exceptional person, having supervised her for 4 years now, doing amazing things. So entrepreneurship policy, very briefly, how long do I have time?
Talk as long as you want.
It will take a couple of minutes, or something like that, if that's okay.
Yeah.
So entrepreneurship policy, I've been measuring and monitoring entrepreneurship in countries for something like 25 years. I was involved in starting a what's known as Global Entrepreneurship Monitor, or GEM for short. And they have been collecting data on entrepreneurship in roughly 120 countries for 25 years now, and still going strong. So basically, when we look at entrepreneurship at the country level, how does it work? How does entrepreneurship contribute to economic growth? So the theory is quite simple. We have an economy that creates opportunities that as perceived by individuals. Some of those individuals actually choose to pursue those opportunities, and that means that they allocate their human, financial, and other resources for the opportunity pursuit. And it is the quality of this dynamic that then keeps allocating resources either to productive uses in the economies if the country's framework conditions for entrepreneurship are appropriate. But it may also allocate resources towards unproductive uses if the country's framework conditions for entrepreneurship are deficient. So the country's framework conditions for entrepreneurship really matter, because the right kinds of framework conditions help support an entrepreneurial resource allocation dynamic, which allocates resources towards innovative and high productivity uses, and that dynamic then contributes to the country's total factor of productivity, which is the country's ability to create wealth. So we have been measuring entrepreneurship in countries, and here is what we find, and this is in response to issues that policy should address. First, countries have institutional framework conditions, which are things like rule of law, enforceability of contracts, government predictability, absence of corruption, market openness, and property protection, especially intellectual property protection. These are institutional framework conditions that need to be in order for a country to support entrepreneurship effectively. Then you have the resource-based framework conditions. We are talking about human capital, financial capital, knowledge capital, infrastructural capital, and government support. But what policies are required today? So what is the general advice here? Well, entrepreneurship is a systemic phenomenon, and recently, through the past 5 or 6 years, people have been talking about entrepreneurial ecosystems. And this is a special type of cluster. A cluster is a regional agglomeration of entrepreneurial activity that seeks to discover how to exploit advances in digitalization for business model innovation. And this is my answer. Governments support productive entrepreneurship in countries. Governments really should focus on fostering entrepreneurial ecosystems in order to facilitate business model innovation that then drives productive entrepreneurship. Thank you.
Thank you, Professor Otia. Okay. This is not
Apologies
intended.
for a long answer.
Great. Our next question is for Professor Robakovsky. Professor, you have led leadership roles at Imperial College Business School, which I believe is one of the most tech-driven business schools in the UK. How do you see the role of technology in driving innovation entrepreneurship in today's business landscape?
Thank you. That's a very good question. So I'd like to maybe list a couple of different categories and then explore them in a bit more detail, especially from the finance angle that I see. So for a bit of context for the audience, in the Department of Finance, we've got 3 research centers that touch on various aspects of technology. So one of them is the Center for Financial Technology that looks, among other things, at blockchain applications and also collaborates with Imperial's Blockchain Research Center. And then we also have the Center for Climate Finance and Investments that looks, among other things, at green tech. And we also have the Brevin Howard Center for Financial Analysis that, among other things, also looks at cryptocurrencies. So the categories that come to mind would be, number one, efficiency and automation. That's one role of technology. access to information and markets, digital marketing and e-commerce, 4, innovation ecosystems, 5, AI and big data, remote work and collaboration, 7, blockchain and cryptocurrency, 8, the Internet of Things, IoT and connectivity, 9, sustainability and green tech, 10, augmented and virtual reality, and 11, cybersecurity. So quite a lot of different categories, but if I look at it from the finance angle, in terms of efficiency and automation, I think that this has been ongoing for a long time, and I wouldn't call it revolutionary. So I'm exploring currently personally a research project on bond markets, which used to be telephone-driven for many years, are now about 50% electronically traded, but this is still a relatively frontier market in terms of innovation, but I think that's relatively well understood. At least in finance, the area of access to information and markets, I don't think that's a new development in technology, so this is also relatively well understood. Digital marketing and e-commerce, I don't see any particular new revolutionary trends, at least from the finance angle. Innovation ecosystems is maybe different. When I started in finance 20 years ago, it was quite siloed, and now we have very strong collaborations along climate finance with other parts of the college, and also blockchain applications and machine learning. And I don't think these will go away. So we're actually benefiting from these innovation ecosystems in a way that I've not seen 20 years ago. AI and big data. I think that when it comes to especially large language models, that's the latest iteration of that particular development. It's hugely important. I see a lot of new research coming out, for example, in the area of forensic accounting, using large language models, which is very interesting. And then the area of remote work and collaboration, I think, as you probably do in your own institutions or organizations, we are still grappling of how to implement it. It's on the one hand an opportunity, but also a huge challenge. So we can collaborate across borders and large distances, but how we keep the social cohesion is still something that I think we are trying to understand better. And then probably among the other categories, just in the interest of time, the one that I would like to mention would be sustainability and green tech. So depending on which geography one looks at, the resilience and natural risks that countries are exposed to very, very, very significantly across continents. And we are engaged in research projects to understand at a relatively granular level what climate change will mean in terms of the risk to assets, geotagging, for example, the risk of typhoons in the Philippines, or wildfires in the United States, or storms, autumn and winter storms in Europe. So I think the area of clean tech and climate finance related innovation is very important and developing.
Thank you. I can see many heads was nodding when you speak, and a lot of the technology categories that you mentioned are also presented in the exhibition, the startups and the design projects today. So feel free to also have a look later after the panel. Our next question is for Mr. John McLean. Mr. McLean, as someone deeply involved in the China-UK relationship, do you think there's more that binds us together than separates us? And considering your unique experience on both countries.
That's a very good question. The key thing is, where do you start? And I have a kind of positive outlook, and therefore I go into any kind of such discussion with the attitude there is more that binds us together than keeps us apart. But that's a very difficult equation when you actually look at the geopolitical situation. And when we talk about kind of entrepreneurship, that that particular question affects your view of uncertainty and confidence as to whether you do something or you don't do something, or whether you postpone doing something. I think what we've touched upon, though, in my mind, there are probably three key areas that are important. One is anything to do with the planet. We talked about climate change, we talked about alternative energy, we talked about pharmaceuticals, we talked about the kind of biodiversity. What we have got to do is find areas of common ground, and if you have areas of common ground, then you can move forward, and that is a binding force. Secondly, unfortunately, because of COVID, the cultural interchange between our two countries has slipped, has split, and indeed I see a significant number of Chinese, Asian members in the audience. You, unfortunately, are a minority because you've come over here. We have very few British people going to China. And because of that, the understanding of China, the sophistication of China, the change of China is not known in this country. So what we have got to do, and you are ambassadors for your own country here, you have got to promote your country to our fellow human beings here, because they just do not understand the change which is taking place. And then thirdly, the trade between our two countries has, over the last 5 years, grown about 20% per annum. Therefore, notwithstanding all of the geopolitical forces that may be kind of pushed against us, business is still continuing. And I think that's what I see. You've got a kind of a different a climate where things are very hot, maybe at political and government levels, but from a practical point of view, people on the ground are just getting on and doing the business. But the issue actually is not what has happened in the past, but what should be happening in the future. And I'll come back to the word of confidence. If people actually have a kind of fear of what may happen next, then they're kind of row back and not do anything. So from my point of view, you've got to start the conversation that you believe things are going to get better. You can find a way to work together. And if you do that, the opportunities will present themselves.
Thank you. That is very encouraging, and also greater responsibilities for all of the audiences today. And now we can move to our next question for Ms. Jill Tan. Ms. Jill, you've created a global community supporting women in STEM. What do you see as the most significant challenges that women working in technology sectors face today? And how do you think we can address these challenges more effectively?
I would list of those challenges in 3-4 dimensions. So first one, I think, is the social system. I guess because, like, say, we're looking at 40, 50 years back, you're looking at the labor force, it was still quite intense in physical presence. So that's why, kind of, in the nature, women more taking in a role at home, and then our allies, men, more taking the work of bringing the bread and butter home. So because of that kind of nature, so when the society evolves, it becomes kind of the stereotype, the status quo. But now, because of the development of technology, the digital economy, we are at the stage having more chances to not compete in a physical way, but have a more opportunity to actually to work in the area that we want to work on. So I think challenge-wise, one is still the traditional social system, and secondly is because of that, we don't have enough talent. So if you're looking at, I don't know about the data, but I think I had the data before for Europe, like maybe for only 0.5% of women only want to study or work in the STEM area. I think globally, let's say for AI talent, women is only 22%. But in China, I think we do have a lot of women study in computer science, for example, even more than 50%. But the challenge is they don't take on the STEM jobs after the graduation. And third one is we don't have enough presence in leadership. So that's why we're talking about the 30% women in the boardroom, still a challenge. I think that's the role model is still a top challenge. So I think that's the overall. That's why we do need the policymakers, business, and then everyone to participate and to move this forward. So, but then again, our panel is called Future Venture, right? So I really think, you know, in the past 40, 50 years, I guess our airline have already got a lot of attention. So in terms of investment. So maybe if, when we're working hard and working smarter, if we can kind of pay attention to the other side of the 50% population, you probably will surprisingly see more progress in terms in an economic perspective. And also, I think education is still the number one. I think it's a mindset. Shifting. So for me, my past 6 years of job is really just changing people's mindset in that perspective, why we should include more women, especially when you're working on that in China. You have to speak language of every single effort or investment into women STEM, how they can reconcile in an economic perspective. So we have to think about how to involve business to drive this social change together. So education, and then how can you justify every effort that can relate to the core business activity with our stakeholders. So I guess that's the, I would say, that would be the top ways that I would engage.
Yeah, thank you, Jill. And yeah, of course, yeah.
Just picking up in terms of diversity, I sit on the FTSE Women's Advisory Board, and this is in conjunction with the government, DBT. And what we have done is we've set targets for all the FTSE 350 companies in terms of whether they're chairs, their CEOs, CFOs, COOs, NEDs, independent directors. And to be honest, that's taken an awful lot of time. And we had a round table in the city a few months ago, and the real key thing, which was a surprise to me, that it wasn't really that women should be promoting themselves. It should be the likes of the three of us supporting how important women are to get a balance and independence and actually stand up for them, because we are better advocates for you than you are for yourselves.
Thank you.
Yeah,
I think we should all.
Thank you. And also just to share a background story here. So last year when we were organizing the summit, we were promoting it and we shared it with the Lady Who Tech community and received a friendly critique that a significant percentage of our speakers are male and not female. So we did learn from that, and in this year we have been putting efforts in encouraging and try to find more female speakers to join the summit, and also our entrepreneurs who are women in technologies as well. So thank you, Joe, for sharing with us that, and we're now maybe moving to the next question. Returning to you, Professor Otiel. Professor, you are an expert in business model design and innovation, and this has been coming up in the panel discussion already. Can you identify some recent trends in the business models of new ventures, and how do you anticipate they will evolve in the coming decade?
That's a really difficult question. Predicting the future is always kind of difficult. But so what do we know about business model innovation? Basically, there's three kinds of innovation, broadly speaking, or four kinds that academics like to distinguish. We have product innovation, people inventing new kinds of products. We have process innovation, making manufacturing processes more efficient, all that. Then we have technology push innovation, taking early stage hard technologies and taking them towards commercialization, so diamond coating technology or something like that. And finally, we have business model innovation. Business model innovation is all about discovering radically new ways for the creation, delivery, and capture of value by businesses. And it's important to understand that this is a digital age phenomenon. So in the old days, in the 1980s, how did you operate as an entrepreneur? Well, you came up with a new product, and then you started making and selling that product. But you didn't have a whole lot of options when it came to designing your business model. How do you actually make those products happen? And digitalization has changed all that. So in the early stages of the internet, what did we have? We had e-commerce businesses. We had businesses setting up a website and trying to sell stuff. We had, new ventures trying to sell sandwiches through the internet. And then eventually, later incarnations, we have these internet marketplaces, Amazon and eBay, which are essentially platform business models, so connecting lots of suppliers to lots of customers and then acting as the middleman in between. And then we had businesses, as internet grew, the need to catalog information therein grew accordingly. So we have these search engine businesses coming up. We have Alta Vistas, and eventually we have Google. Now, Google had a great concept, search engine, but it took actually, if we think about Google, it took them a long time to find a business model that enabled them to monetize. And then eventually they hit upon monetizing data and selling that data to advertisers. And obviously they have been hugely successful since then. Then we have the internet 2.0. We have the read and write internet. What do we see? We see the emergence of social media platforms. Early on, we had MySpace. No one hardly recognizes that business anymore. We had Yahoo's. We had Facebook's. And again, for Facebook, the same thing. It took them many years to actually find a business model that enabled them to make profit. And again, advertising is a big player there. Then we had the third generation internet. The internet capacity keeps increasing and capabilities keep growing. We have software as service business models. Businesses offering various kinds of software capabilities as a service through the web. And again, monetization here is through subscription typically. So what do we have now? What is the latest kind of a disruption, internet-induced disruption that we see? Well, it's obviously AI and machine learning. We have at least two different kinds of AI and machine learning. We have generative AI, which is large language business models, and large language applications. We are generating images and text and what have you, and we have machine learning. Since OpenAI opened their API, application programming interface, for access to anyone, literally hundreds and hundreds of AI and machine learning businesses have been created that try to find concepts that they can monetize and that harness OpenAI's ChatGPT. That's where the innovation is taking place at the moment, but what will those winning business models look like? I think that's yet to be discovered. But that's where I would search if I were you. Thank you.
Thank you. And our next question for Mr. John McLean. You've touched a bit briefly on the differences between the UK and China. How can we navigate these differences? And in your perspective, how can we learn from each other?
That's a big question, isn't it?
It's a large question, I'd say. Yeah.
COVID has not actually done us any favors. And because of that, we actually haven't been to see each other very often. And therefore, all discussions either take place on WeChat, the emails, or Zoom, or Teams. And you can't beat meeting people face to face and actually understanding the perspectives. I hadn't been to China since November 2019, so my first time after COVID was in July of this year. And I went round 8 cities in China to understand the change which had taken place. And the thing that really amazed me was, I mean, we use this word entrepreneurship. this seemed to be an engine which everybody was actually hanging their hats on. But the issue is that I went to Beijing, Jinan, Wuhan, Chongqing, Nanjing, Ningbo, Hangzhou, and Shanghai. So I got an understanding in 2 weeks. But I think the thing was that everybody really wants to do the same thing, but they don't know how to differentiate themselves from the next city. So as a result of that, I'm planning to take a fintech delegation out to China because the appetite is there, and there's the appetite here. I last led the last fintech delegation from the City of London to China in 2019, and I think we were all amazed at the sophistication and the scale and the pace of development. And I think that combination of Britishness and innovation and scale and demand is a win-win for both parties. So coming back to the big question, how do you actually move forward? You've got to find things that actually work for both sides, but also recognize that some areas, let's say whether it be in terms of any form of security, nuclear, are really going to be no-go areas. So if you understand that, take them off the table and focus on what you can do and not what you can't do.
Thank you. And our next question for Professor Robert Korski. Professor, as an expert in asset risk management, could you provide some insights into the impacts of global economic conditions on regional entrepreneurial activities and successful navigation strategies? And I'm really glad that this question really connects with what Mr. John McLean just said. And yeah, on a related note.
Thank you. Very important question. I was reflecting before today how to answer it, and there's, in a sense, a generic way of answering it, and then maybe a very specific country by country, continent by continent, but that would be outside the scope of how much we have time today. So I've decided to answer it maybe in a way by highlighting the most positive aspects that I can see around the world, so as not to offend any continent. So focus on the positives. But before I do that, I wanted to connect to something that John said. He mentioned a very important point that communication and exchange needs to continue. And I don't have as long a list as him to present in terms of where I visited, but I had a chance to attend the China International Finance Conference the year before the tragic earthquake in Chengdu, and also present at Tsinghua University. And I speak sort of to the audience as well. I can see a lot of young faces as well, very smart potential graduates and applicants maybe for our PhD program. So in our PhD program in finance, we invest for 5 years in students, and we want to place them well. We want them to be leading scientists and leading researchers around the world. So, of course, whenever a student then publishes well and goes on what we call the job market and lands a nice position as an assistant professor, we are, in our field, quite proud of that. So when we had a British student that completed his PhD successfully, we had high hopes that he would go on and become a professor somewhere. And instead, he followed his passion, which was skiing, and he decided to become an entrepreneur in China. So we did send someone to China. His innovation, for those of you that ski, was that he focused on improving the technology in ski boots. So there would be sensors in the ski boots that would monitor the skiing and feedback to the skier. But I thought that was an interesting example. It was a huge disappointment for me academically because we lost him to the private sector, but we did contribute to exchange. On a more positive note, one of my PhD students, Tian Yu, he's now an assistant, soon hopefully associate professor at Tsinghua University. So that was a very successful and ongoing academic exchange, and he's publishing extremely well. So the way that I wanted to answer your question regarding regional economic conditions and what this means for development is maybe go through a couple of categories, and one of the first ones is access to capital. So clearly access to capital can take different forms, can come from the government, can come from private or public markets, venture capital, and angel investors. And I would say that if we just broadly speaking look at different longitudes as opposed to latitudes, North America is very well positioned in venture capital and angel investing, and the access to capital there is, I think, something that we can learn from in many ways. And as you know, in this country, there are ongoing discussions as to how to facilitate better access to capital. On the other hand, there are also other countries that are very forward-looking and that channel public funds very successfully. In terms of consumer behavior around the world, of course, differs. John touched on COVID, which, of course, had a dramatic impact on consumer behavior. But the notion of a social safety net, for example, is very important to affect consumer behavior and encourage spending. And there we see very big differences globally between export-led as opposed to consumption-led growth, which leads to the question of sustainable business models and the fact that in some countries we have relatively good medical systems, pension system, a social safety net has very important implications. Now, the two others that I wanted to mention would be the regulatory environment, and there, for me, one of the probably biggest structural elements that I have followed is that about 20 years ago, I was educated by reading a book about the extreme high quality of the academic accomplishment of, for example, government officials in China. And I think this is something that stands out, and a lot of other longitudes could hope to imitate, but cannot. And we see that there's great forward thinking in terms of long-term regulation, which in other countries, unfortunately, it's to very short-term thinking, changes, and difficulty for planning. So I think this is something I wanted to highlight as very positive. And then the issue of adaptability and resilience, of course, matters as well. And during the recent experience, we've also seen that regional economic conditions depend on whether businesses and governments are able to be resilient, either resilient to economic shocks or to natural catastrophes. And I think there have been very big learning points how we have to organize ourselves as societies, both in at the government level, but also at a private sector level, to become more resilient.
Thank you. And now our final question to Ms. Jill Tan. Jill, you run a social enterprise. How do you balance your social mission with financial sustainability, which is very important to a sustainable business model? And do you believe future enterprises should all have a social mission?
Thank you. Thank you for this question. It took me 6 years to realize, oh, I should make money out of what I do. Firstly, let me give you guys a little bit background on the differences between, I guess, you know, as we've seen, sometimes people confuse between charity, non-for-profit, and then social enterprise. And also because of the different setup, to run, when you set up a non-for-profit organization in US or UK, say for example, it's very different when you're doing that in China. So that's why, as I mentioned in my first question, that I really need to figuring out how to survive in a business perspective, right? If you can kind of generate your own blood to be able to survive. So that's why it gave me the natural kind of way to really thinking about how to make it work in our own way. And also I believe in business people is making dollars, but then entrepreneurship is really pushing society forward. So that's fundamentally different. And talking about the social business, I think if you're helping two people, yeah, maybe it's a help or it's charity in a way. But if you're helping 20 million people, I think it's a business. So it took me like a long time to really not be shy asking for money for the things, the value we're creating. And I really think more, all of the social entrepreneurs should make money and should really, get paid on what they have been doing. So I never thought those being profitable and then creating a social value should be contradictory, like conflict with each other. But then again, it requires the social entrepreneur have a product mindset. You cannot be just out there talking about mission and you're not able to articulate on what kind of tangible value you are making, right? So this is one of the things that I've learned in the past 6 years is really to have a product mindset and an innovative mindset for business model, product design, and then to be able to, make it to the market and people understand, oh, this is the product I want to buy. And then that product, if I invest, that in return, it will help us to generate more money and more looking better in a balance sheet. So answering question, I think it should make money. But again, depending on where you are running your business, if you decide to go for a non-for-profit model, fine. If it's working for you, if it's charity model, great. If it's working for you, but I think for me, with what I do, I think social enterprise is the best way. And then, should every business too have a social mission? I think if you're making a value to bigger society, I think every business is social business anyway. And then echo back to John what you said, right? I think everyone's focusing on sustainability because it's good for business anyway. It's really bringing back the dollars and returns on investment on your balance sheet. Because now, what is sustainable business? Not only the financial data, it's only one factor. So that's why people are now talking about ESG, looking at a non-financial disclosure to make sure a company is healthy. So yeah, I think if you are not include a social element, maybe you can think about it, find anyone who's in the ESG perspective. And we're not talking about anything bigger than the 17 SDGs. Just even if you're just focusing on one of them, you can make out of social good and also business. So I think if you don't have it in this element, you should think about it. Otherwise, if you're going to go IPO, you have to do it because it's compliance. So otherwise, I think it's good for your business. If you're already in a social business like myself, then maybe we should really learn how to be innovative and how to have that kind of product mindset.
Yeah, we have 5 minutes for panelists to share, if you have any reflections or remarks.
Can I just second what Jill just said, because what Jill said was very, very important. Today we are facing all these global challenges, so no business cannot afford not to be what we in the Wicked Acceleration Labs call impact business. Yeah. So no business today can only focus on making money. You always need to have a mission to do something good, address some of those global challenges, be they social challenges in societies, or be they sustainability challenges in the ecosphere where we live in. Hugely important. At the second point, very important, there's a difference between charity, someone donates money for good purposes, which is obviously very, very important, and impact entrepreneurship or social entrepreneurship. And the paradox here is that if you really want to create an impact as an impact business, you need to think about the bottom line, financial bottom line. You need to be obsessed about it, much more so than in an ordinary non-impact business. And that's the paradox. How do you do it? By building your impact mission into your business model from scratch and integrate it with your profit mission such that the two, instead of you first making profit and then donating some of that profit to good purposes, create a business model where your impact mission starts driving your profit. And that's the secret.
Thank you, Rico. Does any of you want to share some reflections, or we're going to close this panel, I guess? Just in closing, I would like to extend our sincerest gratitude to our panelists for their stories and insights during this discussion. And we thank you for your time, wisdom, and dedication to shaping the future, bringing innovation and entrepreneurship. And let's give them a round of warm applause. And thank you. And now we can. That concludes this panel discussion.
Thank you so much, guys. Fantastic. Great. So now, last but not least, we have the AI panel. Collaboration with AI and other subjects has already become a trend. But what is the future of AI? What are the interesting stories behind it? Discussing next generation AI and applications of AI, it's time for our fourth and final panel. And moderating is Dr. Cheng Sebo. So please, everybody give him a warm round of applause and let's welcome him on stage.
Please take a seat. I'll put myself at the angle here. So I will leave that. Myself, I don't need that. Okay, hi, hello, can everyone hear me? Okay, great. Welcome. The first thing I would say is like to apologize. So unfortunately, Professor Alice Young, due to personal reasons, will not be able to join us this afternoon. But we have still, as you can see, 4 experts of AI here to have this fruitful discussion. So I hope that will not disappoint you. So first, my name is Sibo Cheng. So I'm currently a postdoc at Data Science Institute at Imperial College. So the first thing I want to say is I'd like to thank you for all the audience. When I saw the schedule, I was thinking, okay, this is the last session of the day, so people may have already left out. There will see many empty chairs here. So we understand, like Saturday afternoon, you may get hungry. There might be football games, right, to watch or to play. Why not? But yeah, it's not the case. So thank you very much, our lovely audience, to be here with us. So very happy, and it's my greatest honor here to chair this session. So we are going to talk about next generation AI techniques. So as you may know, like we have witnessed tremendous growth of AI techniques in the past decades that involves a lot of different fields for things such as medical AI, telecommunication that you will hear today, and also for things like physics or numerical weather prediction, et cetera, et cetera. So I guess today it's just impossible to talk about future without mentioning AI. And this is the reason why we have 4 experts here to join us to have this session to discuss about next generation AI techniques. So at the beginning, I would like just to give our very brief introduction to our speakers. So first, I'd like to start with Dr. Chen Qing, who is a young lecturer in computer vision and machine learning at Imperial College London. And she was recently being awarded by the EPSRC New Investigator Award. So congratulations, Dr. Qing, and very welcome today.
Thank you.
Then just beside is Dr. James Thiel. So Dr. James is a professor of neurology at King's College London. He's also the joint director of data science and artificial intelligence at King's College Hospital. So Professor Thiel, it's my greatest honor to have you here. And we have also Mr. Peter Waggett, who is the IBM director for the Hartley National Center for Digital Innovation. So it's a center that provides AI solutions to nationwide UK companies. And he's also a member of EPSRC Advisory Board. So welcome, Mr. Waggett. Then at last, but definitely not at least, we have also Professor Mazia Nikovi, who's Professor of Telecommunication and Mobile Technologies at University of Sussex. And he's also head of the Center of Advanced Communications, Mobile Technology, and IoT. So very welcome, Professor Nikovi. So I guess I've done enough talking. So the first question, I was supposed is more like a warm-up or ice-breaking questions. So as I said, we have witnessed all these AI techniques in the past decade. So if I may ask each of you to use 3 words to describe the current progress of AI techniques. For example, if we ask random person, that might be things like fantastic, helpful, right? But also, sometimes you see some negative things such as uncertain, risk, etc. So I'm super curious to see from the expert's point of view, what will be the 3 words that you would like to choose? So may we start with Mr. Waggett?
Yeah, I mean, I guess there's, my 3 words would probably be trusted, enhancing, and collaborative. And just a bit of background on that, I mean, you know, I think unless we've got trust in the systems, then they're not going to be of any use to anybody. Nobody's going to use them. Enhancing, I think, is really coming from the background of, you know, myself as a scientist. You know, what I want to be able to do is to be freed up to do the more creative aspects of the work that I'm doing and let something else handle all of the day-to-day activities and the drudgery that goes into some of the preparation of these activities. And I think that, you know, enhancing is going to be needed because, you know, as a society, we're faced with recently the pandemic, climate change, all of these sort of like major problems. They're going to require us to really be on our A game and actually deliver results into that sort of setup. And the final one I had on that was collaborative. And I think on that aspect, you know, really what I'm probably stating is that I don't want people to be AI users. I want them to be AI value creators. And what that means is I don't just want people working at an API level and throwing data in and taking it back out. I want them to actually work with us to deliver something that adds value.
Yeah, please go ahead, Professor Theo.
I'm glad I'm not the last in the queue of words to find. I'd probably choose diverse, open, and explosive. So I've chosen those largely diverse because what we're finding now with AI technologies is that nearly any one of the skill can begin to make one of the growth of open source technologies. Sure. And so this increasing diversity is very, very important. It links with the open elements as well. And I think that diversity increases the level of trust and reduces the level of bias. It improves the transparency and ensures that every individual in every use case, every population, the AI systems themselves would be tuned to that particular situation correctly and ethically. And I think that's one of my main challenge. I think the challenges that face our societies now is how to avoid these AI systems becoming monolithic and monopolistic. And I think that's going to be an interesting question that we'll explore over the next decade, really. And I think my last word was explosive. I don't think we really need me to explain that. There's just been there's a headline every week about AI technology. So I think that's pretty much it. Yeah. Thank you.
Okay, thanks, Theo. And Dr. Jing. So just to remind that you can also repeat the words that mentioned by someone else. Otherwise, it seems like it's not right, fair. Yeah, if you agree.
That's true. Yeah, I think some of my words might overlap with James. So the first word I would pick is fast. We see the advancement of these AI technologies is advancing rapidly nowadays. We know that the large language models got popular early this year, and then followed by these large vision models and also some large foundational models in medical imaging. So this only happens actually within a few weeks since the large vision models actually. So the rapid development of this AI actually I think owes to the second word I want to pick is open. So because nowadays we see the research environment is rather open in terms of both the open source code we can access, the open available public data set we can access, which enables us to have the way that we can benchmarking our techniques and to promote the iterations of these new technologies. And yeah, the third word might be large. Back to these large models we mentioned. So now the trend seems towards the large foundational models we are developing towards. For instance, we in medical imaging domain, which is my area of research, we are also looking at to build models on this large population cohort, where we would like to leverage the data, the power of this big data to learn some population statistics, and then to see how we could tackle or build more generalizable and robust AI systems.
Okay, thank you, Dr. Ching. And Professor Nikoi?
Yes, so I was recently discussing with one of the largest telecom equipment manufacturer in the world on sort of the AI monetization when it comes to the telecom sector. And I want to pick up something from there, which I think is very interesting, this sort of how generative AI, and I work on another sort of particular area called variational autoencoders, which is one of the flavors of generative AIs. Now, I think we are just seeing the tip of the iceberg with that, with ChatGPT. What is happening that, and it relates a bit to your area, that, data, we had a huge explosion of data, and monetizing data was, the big thing, how you monetize on data. Now, what we're seeing with generative AI is that it's not about data, it's that then you can extract models of a very complex system, such as telecom networks or human population movements or whatever. You extract these models from that data, and these models have enormous value. And I think this is going to be a new frontier, kind of shifting from the monetizing data to actually having these models. Now, the good thing about those models is that they're fully anonymized, yeah? So you don't have also all these issues of privacy that you have with monetizing the data, because it's hidden there. So I'm very excited about this sort of new era where AI is able to generate very complex models and very accurate, predictive, in fact, that is well beyond the human capability to do that.
Okay, yeah, thank you, Professor Nikoi. I guess I think all speakers are very positive. I heard like open, trust, transparency, explosive, etc. So to be honest, this is not exactly things I was expecting. Because as myself working in AI, sometimes we discuss with colleagues, we heard also the words like black box, random, uncertain, this. But I think it's a very good thing to have all four speakers here. They're very positive about the new AI techniques. So may I just have a follow-up question? So your positive attitude, how this is related to the ChatGPT release last year? Which I mean is, if I ask you the same question last year without the explosive result of ChatGPT, we say that's maybe the moment that AI techniques hit a little bit the bottleneck at the moment. Would you say that you're always very positive around the future application of techniques, or is something a little bit being biased by the recent success of OpenAI, ChatGPT systems?
Well, I can give an example.
Sure, yeah, please go ahead.
Just to be with the devil's advocate as well a little bit. So I had recently a discussion with a lawyer, and lawyers and courts even starting to use ChatGPT-like software to basically help them. Now, it turned out in a case, with a court case, that some of that previous cases were actually not real. So that was discovered. So I think, we have a way to go. There was a huge excitement on ChatGPT, but then you start to see also some flows into that. I mean, I'm sure in a long run, this is going to be smoothened out, but just to be cautious on using ChatGPT too much when it comes to very critical areas.
Yeah, I'm going to come in as well. I mean, I would say I'm working in this field for 10 years now. I've have to be optimistic all the way, if not you'd give up. But certainly GPT models existed way before ChatGPT. ChatGPT is just a current brand and one GPT model. There are many other these things out there, and we made one 2 years ago before ChatGPT. So it is all useful systems, but they're all prototypes. Because as you say, there are these potential flaws and weaknesses which are being ironed out. And this is, what we're seeing is product development happening in front of us. So we're seeing all the bugs appearing, all the weaknesses, all the issues with the source data, all the potential biases. But these are things which are all addressable. These are all addressable issues. They're technically addressable as well as socially addressable. So in that way, for that reason, I'm optimistic. If we're hitting a scientific brick wall, then that's a much bigger reason to be pessimistic.
Okay. Thank you, Dr. Teo.
Yeah, I mean, I guess following on from some of the stuff that's been said today, I'm very keen in my own head to sort of like make a differentiation between business to consumer, which is really the ChatGPT stuff, and that's not really what I get involved in. My stuff is business to business, and one of the key things that we've found and that I found early on in my career, despite my looks, my youthful good looks, I have been around in this industry for quite a while, and one of the things I found out very early was that unless you understand the data that you're processing, you can't really make any kind of real conclusions on it. So late 80s, there was a big issue around the ozone hole. People were saying, suddenly they'd found that there was a gap in the ozone layer, and that led to a lot of the work that's happening around climate change and sustainability. Now, my background is rocket science. And at that time, I was using the ozone layer as a calibration constant. And I'm sat there thinking, well, I've looked at this data for 3 years, and I've never seen the hole in the ozone layer. So I went back and looked at the data that I was looking at, and somebody helpfully had put a rule in, which was that because the assumption was that the ozone layer was constant, if the data that was being received wasn't constant, it must be an error, throw it out. So all I saw was the data that fitted the rule that had been put into that data set, rather than actually seeing the raw data for me to actually pick these things up. So, like I say, I learned early on that not having got a Nobel Prize for finding the ozone hole, that what I needed to do is always understand the data. And, a rough rule of thumb on a lot of the projects and a lot of the data sets that you're looking at is that, probably about 80% of the time is actually understanding the data. So, long preamble, but what that really pointed me to is that in this new era we're looking at with AI, unless you actually understand the data, the metadata, all the stuff around that data, and you use that data and say in particular in a business-to-business construct, you're never going to be able to trust that data. And trust in the system, trust in the data is key.
Okay, thank you. I guess being optimistic really contributes to the success of all 4 speakers here. So maybe we'll have time to do a more general, another general question. So as I said, we have witnessed the development of AI in the past decades. So from a research perspective, so what do you think that has been the most significant change when performing research for AI techniques now compared to like 5, 6, or even a decade ago? So that can be things related to methodology or related to equipment. Yeah, we'd like to hear from you. Anyone want to start?
Happy to pick up on that. I mean, I think what we're seeing is almost the death of big data. Frankly, we can't afford to keep churning more and more data for less and less added value. What we need to be moving to, and what we're certainly seeing, is that we're moving into an area of, what I'd call accelerated discovery. We're only processing the data that's relevant, and we're using that to draw our inferences, rather than just doing this brute force and ignorance approach of big data and trying to put that across. And I think that's really helping develop what we're doing in terms of AI. And to help on that, we're also providing and we're using new types of hardware. So, AI processors are starting to come on stream, and they're going to be targeted towards developing AI algorithms, and similarly quantum computing, because if we're doing simulations of the real world, the real world is quantum, so you need to do computers that fit in with that. So hardware and a different approach are really, I think, what I've seen over the last 5 years.
Okay, thank you. Anyone want to add something on this topic? Maybe something related to the methodology, so what we do now compared to several years before?
Well,
feel free.
If you like. Go ahead.
Well, I guess 5 years ago, it was all just mainly supervised learning. People were predominantly focused on lots of labeling, lots of source data and labeling, and very kind of niche and point solutions for point problems. I think the last 2 years, we've started to see a lot more general purpose or broad purpose AI models and kind of other kind of approaches which involve very, very deep networks, which obviously require a huge amount of computational hardware. I think the availability of this computational hardware is also accelerated as a result of the collapse of the crypto market, which has allowed a lot of machine learning projects to really take off. I think those things have been driving a lot of it, and obviously the availability of capital now for AI projects. I think all these things are the trends which are happening. I don't know these trends may not necessarily hold on forever, but there may be further trends coming along.
So when you say capital things, you mean like people making more money using AI compared to before?
Investment capital rather than profit cap. So basically investors are prepared to put quite significant big bucks on AI ventures.
Okay, sure. Yeah, that's a very nice new perspective on that.
So I may want to highlight the effort on open sourcing nowadays compared to maybe 5, 6 years ago. We see there is a great effort in open sourcing, whether the code, the data, and also the platform we use for this. I think this is a really great effort in this community, which allows us to move rapidly in this field. Because previously, I think maybe several years ago, in our field of this medical imaging, we mainly work on our own set of data that is collected by our own hospitals, own collaborators. And it's really hard for us to compare with, to benchmark these data sets to see how well we actually performs. But with these availabilities of this, this open source code and data, this becomes possible. And also this is actually, it plays a very important role to moving this field forward, I think. Yeah.
Okay. Yeah, thank you, Dr. Chin. Definitely agree with that. More and more new benchmark, new open access data sets. So I think now it's time. We can jump to a little bit more in-depth questions. Okay, they're not exactly more in-depth, but more specific to the research area of each of you. So I will start with Dr. Chin again. So we know that you are an expert in medical image analysis. So could you provide some insight to discuss the potential of the role of AI in early disease detection and prediction? So of course, through medical image analysis, and how you think this might impact the future of the healthcare system?
Okay, thanks for the question. So I may want to discuss about this early in terms of both from the efficiency side and also at the stages of this disease progressions, maybe. So we know that with the AI, we now can leverage it to improve the efficiencies of this medical imaging workflow, actually from the acquisition, the reconstructions of the signals, to the analysis, interpretations of these images. So for instance, we are working on reconstructing MR signals from accelerated acquisitions. For instance, we can leverage this AI to reconstruct images that's being acquired like 4 times or even 8 times faster. So the save time actually would allow the hospital resources to have the capacity to accommodate maybe more patients for the scanning every day. And we know that this would like reduce the waiting time for the patients and allow the patients could be diagnosed at the early stage of as soon as possible. And another perspective, I think, is on to early identify the diseases before there are any like obvious physical symptoms appear. Well, we see that there are actually some successful cases where we can use these AI-based predictive models for for early detection of severe liver diseases and cancer. And this could leverage this AI by combining the medical images, some laboratory tests, or some relevant personal information to realize such kind of early identification. And it may also enable us to find some new biomarkers before the onset of the diseases and could further improve this early diagnosis of that. Right, and in terms of the impact, I think certainly it's very obvious that can bring significant benefits to the patients. So the early diagnosis would release the burdens for the patients and help them to get in-time treatment. In terms from the perspective of these clinicians, maybe the improved efficiencies of this would save the clinician times on reading these images, etc., so that they can save time to focus more on these patients' cares. And I guess on a larger scale, I think this would bring significant impact to the healthcare system overall, reduce the associated costs associated with the efficiencies of working flow and the delay in treating patients, etc. Yeah.
Okay. Yeah, thank you, Dr. Cheng. It's very, very exciting to hear. So from all I hear is like sometimes AI can be more efficient or even more effective than human efforts. So if you don't mind, I have a follow-up question. Do you think in the future we still need doctors? Or how long you expect that we can get rid of doctors? So let me ask first, is there any doctors here today with us? Okay, no, I don't think so. Please feel, sorry. At least not from the audience. Please feel free to say what you want.
So I already use AI in my clinical practice. I use radiology eyes for stroke patients and such for the last 5-6 years. I know there's a temptation to kind of think of AI as an autonomous kind of does everything kind of AI, but most AI systems are, as we say, just very targeted and specific parts of the workflow. And so it's not happening soon. It certainly helps me with my job. It makes my job a lot easier, with particularly time-critical decisions. And most of my colleagues, particularly in radiology and such, all feel that this is the direction of travel. They're not threatened by it. I think Eric Topol predicted a couple of years ago that we wouldn't need radiologists in 5 years. Well, 5 years have passed, we need even more radiologists. So I think often the predictions are sometimes in the wrong direction.
So collaboration is always better than replacement. Right? So, Mr. Waggett.
Yeah, just following up on that, having spent a large amount of money supporting my daughter through medical school, I have absolutely no intention of making her redundant before she pays some of it back. But a more serious point is that I think that the current crop of doctors is a different generation. They've grown up with this technology and they're much more familiar with using it. So probably about 15 years ago, I was involved in building up a system to give automated analytics of, in fact, it was mammograms, so breast cancer imagery. And at one point, we built in a better set of functionality that said, basically, I'm not sure, press a button, and this will get you a second opinion. And it effectively went out to a forum because we didn't have the tools around to do the AI activity. However, when we were working with the doctors at that point, the statement we had from leading surgeons was, why would I need a second opinion? And that mindset was that the doctor knows best and therefore we don't need to ask anybody else. But the current crop of doctors coming through are really in tune with that. They want to get a second opinion. They want to get the best outcome that they can for their patients. So, you know, I think that change in the culture of the doctors as well is helping us move forward.
So I think, again, diversity is very important in that question. So I'd like to continue, but I think we have to move on for the next question. So as just for Professor Theo, so we know that you have contributed significantly in the natural language processing in medical AI. So my question will be, so how do you think the large language models, so as we have discussed, ChatGPT, also maybe like Llama, how these shape the future of natural language processing in medical AI?
So the biggest thing that has had an impact for me is that I don't have to explain to people what a language AI is now in the last year. Before that, I spent all my time, the first 10 minutes, trying to explain what I did. I think a lot of the work, effective stuff, will still happen at a small language model level because it's so much more flexible and so much more easy to tune. Large language models definitely have what we call emergent properties, which are very impressive. They are computationally quite expensive to actually use. I would say that I think we will be discovering a lot about their uses, particularly in kind of workflow tasks, like summarizing and looking for patterns within the data, rather than necessarily for kind of diagnostic purposes. Yeah. I think they are very good at writing, but what they write isn't always reliable. Language models in the past have been used mainly for reading rather than writing. And there is a lot of value to be gained from just reading alone. And actually, that's most of my work has been actually building the language AI to do the reading of patient records. And we have, you know, thousands and tens of thousands of people just hired to read and transcribe. This sort of activity can be accelerated. So that reading process, I think, is something that will happen in the near term. In the longer term, then the large language models will really kick in, because then you will start to see this orchestration of these different functions and how they write, whether they write to each other as well. So then you can have these kind of agent-based AI systems which communicate with each other and perform more complex tasks. I think that's the direction of travel. I think the main, because to avoid being overly optimistic, as you said at the beginning, you have to have always a potential for a dark side. Obviously, the dark side is that these models are potentially quite biased. They are very based on the data that they are trained on. So we need to be pushing for open data as well, not just an API. An API, you're a customer, you're not actually seeing what the product is behind the wall. The other aspect to think about is the quality of the data going through the systems. As we know, many of these models were trained on, you know, all sorts of stuff which we do not know the veracity of. And I think that's resulted in a lot of what the issues. What we need to move towards in the large language models is openness of the data, standardization of the data, frameworks for exposing the data for regulatory purposes. I think all this will happen. And last little thing I probably should mention is that although we call them large language models, language just happens to be the first thing that they're used, they gain their success in. These are transformer models. And these transformer models seem to have a very broad utility across many different domains of data. So not just, not just language, but also, as others have seen, in genetic sequences or in any kind of timeline-based activity. So we've been modeling whole patients as a transformer model. All these things, I think, will change the way we call language models. And I think we would prefer to call them transformer models or foundation models rather than LLMs, I think.
Okay, thank you, Dr. Theo. That's very insightful. So I guess if I can summarize what you're saying is that these large language transformer-based models, they're very promising, but they can be more like helpful in the future, like long-term future, compared to short-term future. Maybe we still rely on these small models.
Yeah, we're seeing the prototypes now. I think there are much more effective small language models out there.
Okay, great. Thank you. Now I'd like to go to Mr. Wagit. So we know that you have led the IBM Digital Center for several years already, since several years before. And all the other speakers, as you can see here, they represent more the academia perspective. So I was wondering from an industry perspective, so what do you consider the most promising direction of AI in the coming decade? And also, what are the breakthroughs that you're expecting in industry that you will anticipate? Thanks.
So, yeah, I mean, following on from what's been said, large language models is a bit of a misnomer. I mean, we call them foundation models, and we've developed them into a technology that we call Watson X. And really, what we're looking for there is that we use those foundation models to get us in huge improvements in productivity, to get to the point where we can apply these models to individual cases and get much increased efficiency. So almost like these platforms based around foundation models, including huge amount of open source capabilities. So we're connecting with Hugging Face, we're connecting with Meta's Llama 2, making all of this available in an open environment such that you can go in there and work with us to co-create. And I think that co-creation is really why we've built this project with UKRI through the STFC called the Hartree Centre. And really what that is that it's a hardware platform, and as I said, the hardware platform will evolve. We're not just talking about bits and bytes processing, we're talking about AI processing, so that's AIUs that are able to make more efficient processing, supplemented with quantum to give us that physical dimension in terms of simulation, and providing all of that capability. Now, we know that we're not the complete answer. And like I said, I don't want people just becoming AI users. I want them to work with us. So as part of the Hartree, what we've made available is this platform, so that's machines, it's people, and we want to work with organizations. And so the organization comes to us, and we want them to come to us with real challenges. And that, I think, will help drive the industry forward and also help drive the capability forward. So don't come to us with, I want a 5 or a 10% improvement in performance. I want you to come to us with something saying, we need to make a step change. We need to go 10, 100 times faster. And we need to do this sort of capability. And, for us, there's where the real advances are going to come. You can rely on ourselves and you can rely on the industry to get that capability to support you, but you need to engage. And as part of the program up there, we're providing free training courses. We provide free people to actually work with you to get proof of concepts. So it's that co-creation activity that's really going to drive the industry forward.
Thank you, Mr. Rocket. So I think here you're mentioning like explainability is also very important in AI, not only about the accuracy, etc. Okay, so I think now I'm going to Professor Nikovi. So we know that you're an expert in telecommunication, and in particular, you have led the development of 5G network in the UK and also in Europe. So my question is how you think that 5G techniques, or in general, advanced communication techniques, have influenced the AI industry and vice versa. So basically, how telecommunication helps AI and how AI helps telecommunication. Thanks.
Thank you very much. So yes, I was deeply involved in developing 5G, which is the current generation of mobile computer standards, previously having Samsung's 5G R&D in Europe. And it's very interesting because, the 5G standards, they have a lifetime of 10 years. So research really starts around 2013. And then the standard is available for commercial use by about 20 around that area. And then you have the next standard, which is 6G, and that is going to be in 2030. So there's a decade of very intense research by industry and academia before this standard is available on your mobile phones. And we're all happy to use it. How many people have mobile phones here? I think everyone. So most of you have now a 5G modem in that. Now, when the standardization was happening, that was really at the moment that artificial intelligence in a kind of quite a big time to start to take off. That meant that the standard work went a bit parallel on what was happening then in AI. So really didn't embedded a lot of AI into 5G standard. There is some. So in your mobiles has some of the artificial intelligence, not for the communication, but for other aspects. But the biggest, so the biggest impact of artificial intelligence, I could start from vice versa. So just to go back to how many mobile phones you have. So there are about maybe 3 to 4 billion mobile users now in the world, so it's not 100%. Now, how many of you know how your mobile phones connect to the internet? Well, that's a really interesting question. You know, it's magic, isn't it? It's kind of you connect to the internet, but you're not actually, you don't see how it happens. So there are other things, these antennas that you see on the side of the roads or in the streets. These are called 5G base stations. So you may see them somehow. As I pointed to my students. When I was traveling, taking this wonderful high-speed train from Beijing to Shanghai, I was amazed by the number of 5G base stations you see, and it goes very fast. So only in China, there are about 3 million 5G base stations. Around the world, maybe there are 10 million or so. Now you have about 4 billion users that are connecting to those in order to do video, audio, chat, Facebook, holography in the future. And as you move at very fast speeds, that they have to keep track of all of that. Now, and add to that, maybe about 20 billion new IoT devices, Internet of Things sensors, that all be connected to that network. So really, we don't see any of this, and we seamlessly connect, and we obviously are not very happy if it's not working properly. But it's an enormously complex, hugely sophisticated piece of engineering. It's a network of a very complex, sophisticated network. Now, so far, we have been able to keep up managing this huge network with the human in the loop. So if you go to telecom operators' control rooms, you still have panels where there are humans who are, operating. So the biggest, really, part that the AI is now playing is to what we call to take the human out of the loop. So this management of this complex telecom networks is going to be fully automatic. Because, if you have 20 billion new devices, you cannot do using human. So that's the first part. The other part, AI is playing a huge role, I think, not only in telecom, but other sectors, is energy efficiency. Now, AI has a big energy bill as well, so that I'm not going to discuss that. There are innovations to address that. But if you could have the bill of operators, so in the UK, Vodafone, BT, others, China Mobile. Now, the 20% to 30% of their operational cost is at the moment the cost of energy. And that's really the cost to connect your mobile phones to the internet. Now, with the current energy situation and prices going up, this is going to be maybe 40% in 5 years' time. That also creates a lot of, not a huge amount, but large enough emissions. So they're reducing the emissions and sustainability is also a very big issue. Now, AI is going to play a very important role in reducing the energy consumption of mobile networks. Because at the moment, even if any of us are not using your mobile phone, there is still these 5G base stations that are lighting up and trying to connect, and that costs energy. So the AI is make that happen. So that's one side. And just to go to the vice versa very shortly. So I mean, what I'm really excited about AI is that AI is going to be embedded coming out of our computers to and data, and extremely important, into the physical systems. So we are talking about cyber-physical artificial intelligence. Obviously, autonomous car is the biggest example. Now, Elon Musk is now also moving to robotics. So robotics is another example. Now, at the moment, obviously, robots are extremely important for productivity, but they are sort of chained, so to speak. They're in factories, in controlled things. The next wave of robotics will be consumer robotics for care of elderly, for retail, for other areas. These are going to be mobile robots. Now, these robots need much more intelligence than the robot arms that we are seeing going up and down, but obviously important because they have to interact with humans, they have to interact with elderly, they have to interact with children. And that sort of level of intelligence, it cannot be, or maybe in the future, fully embedded into the robots. So that intelligence has to come from somewhere else, and that's where 6G, the next generation of mobile networks, will be creating that sort of cloud intelligence that then will power the next generation of sort of robotics and other areas. I think that's the biggest role we're going to play as telecom.
Yeah, thank you, Professor Nekovi. I think it's so lucky for us to know that we're in AI industry with so many, get so many support by the telecommunication techniques. So I think when we talk about mobile data, as mentioned by Professor Nekovi, we naturally will link that to the privacy, right? So especially now we know how powerful AI tools are, that we may naturally think about how we can keep the privacy, at the same time benefit the power of AI. So I think I have a follow-up question, but it's not only for Professor Nekovi, so for all four of our speakers. So when we develop these either large or small AI models, there are always questions about fairness, transparency, and also the privacy. So is there any concrete steps already taken in your domain to protect that either privacy, transparency, and no bias, etc.? Any volunteers?
I mean, I guess, from my perspective, as I said, I divorce what's happening with business to consumer to business to business. In business to business, the risk needs to be managed and contained. So, we cannot afford to have privacy breaches in the systems that we developed. Whereas, if you looked at, say, an application that was out there to, say, recommend a restaurant, what's the worst that could happen? You can get a bad meal. But, if it was something that was looking to make decisions about employment or anything like that, you have to absolutely protect the privacy and ensure that it's transparent, it's open, there's no bias that's gone into those sort of decisions. So that sort of risk-based approach needs to be applied across all of the applications that are developed. And we need to account for that completely.
So obviously, as a doctor, privacy is a big factor for my patients. I'm also a member of the Health Research Authority's confidentiality advisory groups. So we make decisions about the use of confidential data. And privacy is a big element. I think there are lots of approaches that we take around anonymizing data within our organizations, as well as at a national level and regional level. I think the level of anonymization, the more you anonymize, the less useful the data is. Because you essentially lose the characteristics which allow you to use it for new insights, but you also lose the ability to, all those characteristics also used for re-identification, could potentially be used for re-identifying someone. So one has to balance out those risks. I think a lot of these are very, very scenario specific. So as you've mentioned, having the privacy of your last meal at a restaurant and your restaurant review being compromised is not necessarily the most disastrous thing in the world, but a much more detailed information about your genes on your illnesses would be extremely impactful for you as an individual. So I think that these privacy aspects can be addressed, however, through other mechanisms. So the traditional way of doing this would be to centralize data and to send data somewhere to do a lot of the processing, machine learning, and inference. One could move towards a much more federated model or edge computing, which then could handle a lot of this. So all the computation and all the data stays local. And I think obviously that would also help some of the 5G, 6G aspects, so that there's a lot less movement of data unnecessarily with high energy consumption. Obviously, there's a variety of new approaches may arrive, swarm intelligence, there's all kinds of alternative approaches, but I think these are all ways to address privacy element. And lastly, there's one other way which involves the use, rather than you working on source data, converting the source data into what we call embeddings. So what AI systems now are able to do is encode the information in a very abstract way, and to work on the embeddings rather than the source data themselves. And that is one way of perhaps handling the privacy element.
Thanks, Dr. Thiel. I think your points, like there's a compromise between accuracy or powerfulness and the privacy is a very interesting point. And sounds like a new PhD at this topic. Okay, I know that maybe we're a little bit in short of time, but there's another question I really, really want to ask. Is we know that today I think that'll be quite relevant to our audience as well. There are many young students, many young people would like to get into the AI industry, either industry or research. So, of course, we have witnessed all the power of AI. So, as experts in this field, if you can give some suggestions to our young lads who want to get into this field, what will that be? So I would appreciate if you can make that concise, maybe each one of you 3-4 sentences. Would that be possible?
I'm happy to take this up because we really have a shortage. So there was a question asked about what is the biggest obstacle of AI adoption, huge opportunities in my sector, in the mobile telecom sector. A lack of skills, people, and simply because they are all, taken by other players in the game. So really, there is a huge shortage of, I think in the future, in our sector, people with AI skills. But I think what is really needed is people with AI skills, yes, but they also have to have some domain expertise. So this intersection between artificial intelligence and different domains, I think that's where there will be a huge demand for, and therefore sort of a hybrid, studies where you do AI with engineering or AI with telecom. I think there will be huge potential for those.
Thank you, Dr. Niket.
I mean, certainly from my perspective, I'd reinforce that activity. There is a huge shortage. As usual, when there's a shortage, that's an opportunity. So, if you're out there interested in trying to get into this field, there's huge, resources and assets you can tap into to get it. So, as I say, with the Hartree, we've got a whole series of technical training courses that are available for people just to log into and check for free. And, that will get you started on this sort of journey. But I would hope if you are interested, you won't be disappointed in terms of being able to find a role because there is a huge shortage.
Okay. Thank you, Mr. Agate.
So I might suggest, because now we know there's so many hot topics on this foundational model, these large models, and I would actually suggest young researchers to pay more attention to some other fields that have been not really got attention these days. There are more things than just large models and foundational models. For instance, I think some of the edge AI that James just mentioned would be quite interesting as one potential application of how we leverage these large models afterwards. And there will be also other areas of research, for instance, like how to involve human interactions into the AI things. So, yeah, from my side, I think people tend to, young researchers might be attracted to these hot topics and got involved in that. But I would suggest to look a bit broader to some other areas that have been ignored recently. Yeah.
Thank you very much for sharing, Dr. Qin.
I would recommend to work on projects and to work a lot on project-based work. So that project-based work will allow you to acquire the skills as well as the domain expertise. I think domain expertise is a big factor here. A lot of machine learning projects I've worked with others over the last decade. The ones which failed were ones where the machine learning researcher was too abstracted from the source data and the industry needs. And so I would recommend for people to work very closely to people who are already working in that space, in that particular industry or particular business or the particular problem that you're trying to solve. I would suggest that this would be, likewise, there will be skills exchange on that front. I completely agree that these things come in trends. There will be another new trend, but whatever skills you acquire, you should be acquiring which fairly generically. So these are kind of broad software development skills, code development, kind of quantitative thinking. All these things should be broad, whereas the domain expertise can be more kind of targeted.
Okay, thank you very much, Dr. Thiel. As I said, I can continue this forever, but unfortunately it's already time. So I think it's a very fruitful discussion with all the speakers. I personally enjoyed a lot and learned a lot. I hope the audience do as well. So at the end, I'd like just to thank you again for 4 speakers today here with us. It's my greatest honor to host this chair and to discuss with you. Thank you.
Thank you very much.
Hi, thank you very much, guys. Absolutely fantastic. And I have a quick announcement. The Chinese ambassador to the United Kingdom, Zhang Ziguang, would like to wish his best wishes and say congratulations to everybody at the event today. Unfortunately, he's in Beijing at the moment, so he couldn't make it, but he wants to say that he wishes he was here, and congratulations, gongxi, to everybody involved. And that wraps up the day, so unfortunately, the show must come to a close, but thank you so much to everybody. Congratulations, and we're going to invite all our special guests, please, up on stage. We're going to take a big group photo. So everybody, all the panelists, all the collaborators, everybody, the team, please join us on stage. Yeah, try and get a final photo. Thank you. See us here. Peace and love.
I'm excited to hear about 6G now. Yeah, I can tell you all about it.